Hi, I am Faruza Amira.
Hi, I'm Geeta.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Sakinah Ahmad.
Hi, I'm Khalida Jassi.
Hi, Assalamualaikum. I am Nur Intan Raihana Ruhayim.
Hello everyone, I am Nur Zarin Zulkarnain.
Assalamualaikum and hi, I am Hamira Hania Abdurrahman.
Hi, my name is Farizana binti Hamzah.
Hi, my name is Nurul Akila.
I am currently a data scientist at ST Microelectronics and Chief Operating Officer at Ever AI Technologies.
I'm also the founder of startup Jenga.
Currently, I'm Associate Professor in the Department of Intelligent Computing and Analytics, UTeM.
I'm also a statistician at WAI.
I am currently a senior lecturer at the School of Computer Sciences, University Science Malaysia.
Currently, I am a senior lecturer at the Faculty of Information and Communication Technology, University Technical Malaysia Melaka.
I'm also a senior lecturer at the Faculty of Industrial Management, University Malaysia Pahang.
And currently a second year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Currently a final year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Women in AI is awesome,
Engaging,
Remarkable.
Passionate and dedicated.
And a great platform for building friendships.
so
Let's join Women in AI Malaysia Summit.
Summit. Hi, good morning, ladies and gentlemen. Welcome to the second day of Women in AI Malaysia Summit. It is my pleasure to be a moderator for this WAI Masterclass Robotic in Industry 4.0. I am Nur Intan Raihana Ruhayim on behalf of WAI Malaysia Summit Committee. Let me begin by giving you a warm welcome to Women in AI Masterclass Robotic. We appreciate you taking time off your busy schedules to join us today. We hope you will learn a lot as we have lined up for you to be fruitful and engaging. Are you ready for the second day for the summit? Are you interested with the topic offered this morning? If yes, I am sure that you are ready to ask questions to our speaker. Ladies and gentlemen, you have probably noticed that women love robots. Why am I saying this? Of course, because of that they can save your time and energy, especially for cleaning. Just list them: robotic vacuum, window cleaning robot, robot mop, pool cleaner, robot laundry folding robot, automatic litter box, and list goes on. Believe it or not, the list become longer during our MCO3 in Malaysia. If you don't trust me, you can try sneak a look at your wife's Shopee cart. Ladies and gentlemen, it is an absolute honor to bring to the event A very first male representative of the event, Dr. Muhammad Nadir Abdul Wahab, a senior lecturer from the School of Computer Sciences, University Science Malaysia. Dr. Muhammad Nadir Abdul Wahab received the Bachelor of Engineering degree with honors in Mechatronics Engineering in 2010 and the Master of Science degree in Mechatronics Engineering in 2012, both from University Malaysia Perlis. He obtained the PhD degree in Robotics and Automation System from the University of Salford, United Kingdom in 2017. He is currently working as a senior lecturer at the School of Computer Sciences, University Science Malaysia. His main research interests are artificial intelligence, mobile robotics, computer vision, optimization, navigation, and path planning. As a record, Dr. Nadir participated in National Instruments Autonomous Robotics Competition for 3 years in a row and won second runner-up for the third edition. WAI Malaysia and UTeM would like to thank Dr. Muhammad Nadir for taking time sharing his insights and experiences today. Dr. Nadir, the screen is yours.
Right. Thank you very much, Dr. Intan, for your kind introduction. My name is Muhammad Nadir. First of all, I would like to thank WAI Malaysia Summit and as well as UTeM to invite me as one of their speakers. And it's an honor to be the first male speaker. I hope that I didn't let all the guys down out there. So today we will discuss about the topic, which is Robotic Industry 4.0, the past, present, and future. But perhaps later we will see how this topic can relate to your present as well as your future. Okay, so first of all, we would like to discuss about the Industrial Revolution or industry. Some of them say the Industrial Revolution, but some of them just say that it's just industry, just one revolution before the Industry 1.0. So we have four industry revolution at the moment. So to understand each of these industry revolution that brings technology to the table, I think it's better for me to share with you a simple example, which is I get from my mentor. So he said that if you want to understand the Industry 4.0, you have to see the example that is very close to you. So the example that he shared with me is for industry, not Industry 1.0, but Industry 0, which is the first industry. So taking example of Makcik Kia that making a curry puff, right? So when she started making the curry puff, she didn't have any power tools or machine to help her. So everything will be done manually and then gathered manually, fry the curry puff manually, everything. And then coming in Industry 1.0, which is the revolution of a power engine where you have a machine starting getting a machine. So here is where the machine will help Makcik Kia to prepare the ingredient for getting the order of curry puff ready, either the crust, either the filling. So if, for example, Makcik Kia have several filling, then she has to prepare several ingredients of the fillings. Then this Industry 4.0, the machine will help her to efficiently prepare it and increase the productivity. Then goes to the Industry 2.0, where is the mass production and assembly line started, and we have an introduction to electric energy. So that's why the segregation of the task is being given. So there will be a production line where one of them is preparing for the crust, one of them preparing for filling, and another one perhaps do the frying and then do the packaging. So that's how is Industry 2.0. Now when moving to Industry 3.0, this is where automation. The difference between the Industry 2.0 and Industry 3.0 is when Industry 2.0, everything is still prepared by using a helper machine. Only the assembly line have a dedicated assembly line. And then when you're moving to Industry 3.0, this is where the automation, there's a robots coming in that helping to prepare in terms of sorting the package for the shipping and so on and so forth. So now, the era that we are in right now, which is Industry 4.0, it includes IoT, cyber physical system as well as network. What's the difference between Industry 3.0 and Industry 4.0 is the introduction of this Internet of Things as well as a cyber physical system, where you can customize through your order through a mobile application. Everything will be done automatically. So Achkia don't have to worry about the productivity anymore. Everything will be done autonomously. The customer will get the order through a mobile application, for example. Key in, I want 3 sardine curry puff and 3 chicken curry puff in one packaging. Everything will be done automatically, and then the product will be shipped to you. It will be notified. It's on its way to you when you and then expectation, your estimation of receiving the item as well as I know that all of you are familiar with Shopee, so you can track your order where they are now, so that you can prepare yourself to receive them. All right, so we have talked about the Industry 1.0, even from Industry 0 until Industry 4.0. Now we want to see what's the pillars or the core main of technology within Industry 4.0. So we have actually 11 pillars identified by Malaysian committee. So one of it that our interest today is here, autonomous robot. I think other speakers have talked about other artificial intelligence, about a big data, supply chain as well. But today we'll focus about autonomous robotics. Okay. So before we go to learn more about robotics, we need to know how this word is coined, how it has been created. It's not coming from a scientist to be surprised. It's actually a Czech word, which is derived from a word robota, which means a forced labor or mean a hard work or slavery. The first words is actually introduced by Karel Čapek. He is a screenplay that introduced this word through a theater known as, I'm not sure either I can pronounce it correctly, Rosomovie Univerzalni Roboti, or in Rosum, Universal Robots. I'll share with you some of the screenshot on the play that he did in 1920. Okay, although he only introduced the word and then introduced the concept of it without an actual robot, it's actually leading to a robot revolution, and also ultimately the birth of a new robot society. Okay, so here is a Karl Čapek in 1938. So he is an author. So he is the one that created the words robotics, robot actually, and then coming with a robotics. And then we can understand let's see what's the component of robot. We know robots is actually the one discipline that is conceived of multiple area or multiple discipline. This is a simplified version of a component that required to make a basic robot, which is a power source. Either you can have a pneumatic, solar, or nuclear. Then you have actuation. Actuation is more or less the things that will react towards the world. Okay, for example, your electric motor, so your hydraulic drive, that kind of thing. So sensing is actually the senses, either how you perceive the data or the reaction from the world. Now, how can you make the robot understand? Then the manipulation as well as locomotion. Okay, so this is the simple, as I said, the simple component to making a one robotic system. They're actually more than that. They're actually a 7 core of discipline that have been integrated together to make one working robotic system. So as you see, first one is the power source. You can have a lot of a power source. You can have an electric power source. You can have a pneumatic as well as hydraulic. Then you have an actuator, as I said. You can have electric motor, air muscle using a pneumatic, muscle wire. There's a lot of it. Elastic nanotubes as well. Then the next one, you need a sensing, which is either a touch sensor, a vision, which is you equip a camera to your robot, and then pair them with the deep learning technique for image recognition, object tracking, so on and so forth. So you have as well a touch sensor, and you have a lot actually, hundreds of sensor, either infrared, either ultrasound sensor, as well as a LiDAR. Then you have a manipulation. Manipulation is basically known as a gripper. Okay, what's the end effector that connected to the robot system that will react to it? So some of it have a gripper, or vacuum gripper, or mechanical gripper. Perhaps we are very familiar with mechanical gripper that looks like a hand, but there's also other gripper that can be attached to a robotic system, which is a vacuum. So the next one, we have a locomotion. Okay? The locomotion is actually the component that help the robot actually to know itself, so that it's don't lost in the environment that it currently in. So however it moves, either 5 step forward or 5 meters back, it know exactly where's the position, so it don't lost within the environment that it is in at the moment. So that is a locomotion system. Still requires some sensors, but it more for the internal information rather than reacting towards the world environment. Then we have the 6, which is the interaction and navigation. Okay, so this is another component which is important for robot as well, to do such as obstacle avoidance, the path that you want to create, so that you don't collide with any obstacle within your path. Then we have the final one, which is human-robot interaction. Okay, how you can read the facial expression, how you can read the artificial, how you can give artificial emotion to the robot. So one of the most common robot that have this kind of interaction is a humanoid robot, such as Sophia. Later I'll show you some example of it. Okay, next one, we want to discuss about a law of robotics. Perhaps not many of you, especially the one that not within the robotics field, know about this law of robotics. We can hear all those talks saying that the robot will replace a human, but actually this is the law that created by a professor of biochemistry, Isaac Asimov. So the robot that developed by Honda previously, Asimov, is actually inspired or actually taken from this gentleman named Asimov. So he wrote many early books that related to robots. Then the movie I, Robot is actually based on his book as well. And the Foundation series that made to an Apple TV series is actually one of his book as well. So he famously created these 3 laws of robotics, which is the first one: a robot may not injure a human being, or through inaction allow human being to come to harm. Means that in any circumstances, the robot is not allowed to injure a human or person on purpose. So the second one, a robot must obey the order given by human, except where such order conflict with the first law. Means that whatever the orders that given or instruction given by the human being, to the robot, it will do those orders. Only that if it contradicts with the first law, then it has to stop itself. Then the third one, a robot might protect its own existence as long as such protection does not conflict with the first and the second law. Mean that it have to protect itself from being harmed by others, but must not injure the human and also follow the instruction or orders given by the human. Okay, so this is Isaac Asimov, the professor of biochemistry, the handsome gentleman right here. Right. So before we go for more intense stuff, so I'll just introduce to you a few words that perhaps I'm going to repeat several times during my presentation, during our discussion. So the first one, the human-robot interaction, is a field that to study the relationship on people and machine, how that it can interact between the human and machine. So, for example, as given here, a self-driving car could could see a stop sign and hit the brake at the last minute, but that will terrify the pedestrian and passenger alike. By studying human-robot interaction, robot can shape a world in which people and machine get along without hurting each other. Okay, so what does it mean here when you have a proper human-robot interaction? When you have a self-driving car, it doesn't make a emergency stop, but it gradually stopping when they see a stop sign. That's one of the example that's given. So the next word is a humanoid. So the humanoid is very common for people to see. If you're talking about robot, so the humanoid type of robot is the first thing come to your mind. It looks exactly like a human, where you have an arm, you have a leg, and you have a head. Look exactly like human but all mechanical. So that's a classic science fiction robot. Even when Carl Sagan introduced the words robot, firstly, then how he visualized the robot is actually like a human. So humanoid is one of the first science fiction robot that have been developed. Okay, so we have a soft robotic as well, where soft robotic is not it's not your conventional robot where you can't actually see the shape. It perhaps coming in a different form. I'll share with you as well the video as well as the picture what is a soft robotic. So the actuator, we have discussed about the actuator. It's the one that your system react towards the world. So how it's going to move, how it's going to, for example, pick and place. So the gripper itself going to take from one conveyor and put to another conveyor using this actuator. Okay, the LiDAR, or known as light detection and ranging, are very common to be used now in self-driving car as well, and it's robotic because of its precision, because it's using a laser, and you can build a map, a 3D map while you're moving actually. So it's very crucial component, especially for a self-driving car and as well as service robot, so that you don't want to hit to a human being especially, or any obstacle that may cause harm to the human as well. Then this is the most interesting words or term, which is a singularity and multiplicity. So the singularity means that the human will be forced into existential crisis, means that all the robot will replace the human. We don't want that. We want a multiplicity where the robot and AI is not going to supplant the human, but it will complement us, and then they give us advantage, or we call good things that can increase our efficiency as well as our productivity. Okay. So now let's see a robot revolution on how robot has evolved from early 90s to the current type of robots. Okay, the first one, this is what's the play by Carl Sagan in 1921. Okay, the Rossum's Universal Robot. As I said to you, when he started this play, when he imagined the robot, he imagined as a human. Although this look, if us looking today is exactly like human, but that's how he visualized or he pictured robot will look like in the future. Okay, so the next one is is another play, actually, a film called Metropolis. And it introduces another humanoid robot, but this time it's a female robot. But this time they are they are less looking like a human. If you see here, the face is no longer like human as a previous play by Carl Chapek. So that's how it evolved just within 6 years. Okay, so the next one, okay, this is actual autonomous the first self-driving car, I will say. So this is the first idea by Stanford University, a Stanford car, where it start to navigate autonomously. But if you see, it's nothing to look like today's car. But the principle more or less is there. They have a battery, they have even a camera to react and navigate through to a road without colliding into any obstacle or human being. This is in 1960. And then we have the Shaky in 1966. So this is a machine that been developed around 66 to 72. This is the first mobile robot. So if you see is how bulky it is compared to our current mobile robot, which is more small, more because it comes with the technology as well. As technology evolved, the computer getting smaller, and even now you have a Raspberry Pi that can react exactly as a CPU, which has saved a lot of space and actually reduced the needs of power source, a lot of power source. If a bulky like this, when you're moving, you are carrying the heavy item. So actually, your robot needs higher power consumption. So when the technology evolve, and then you no longer need a desktop, for example, like this, like a big computer on board. So it saves a lot of space, as well as it getting lighter, and the battery or the power consumption needed by the system will be significantly less. So what it does is more or less similar to what we have today. It can actually take a picture and then perceive the environment, and then can actually give you an idea on how it looks like if the environment or the place cannot be accessed by human being. Okay, so this is another play. I think all of us are familiar with these two figure, C3PO and R2D2. Actually, both of them is not a robot. It's actually a costume played by human in the Star Wars. But how they inspired a lot of people to join in a robotic field is actually tremendous. Okay, so that the next one we have Terminator. So why I put a Terminator within my presentation is when this Terminator movie came out in 1984, it actually, although I wasn't born at the moment yet, at that time yet, but this film actually give something within the roboticist researcher something to think about. How can you create something that can be very harmful to the human? So the robot that very harmful to human. So that's where they got the idea to have those emotion within the robot, as well as the robot to have the feel of pain. Okay? So that it not only serve the what called the laws that I've talking about earlier, but it's actually prevent the robot from actually hurting a human because they have those feedback of painness in their system as well. Okay, so this is another famous robotic system, which is Mars rovers. Now we have more. We have a Discovery as well, but Mars rovers is one of the initial um, space robot that have still been developed until today. We also have opportunity and curiosity as well. Then, if you see this, the shape is starting to look different. Although it's a mobile robot, but because of the structure or the surface in the Mars is totally different uh, with Earth, so that when they want to navigate around, they need to have some robustness. So it can't have a fixed wheel to do all those navigation. That's why they come out with those different type of mobile robots. Okay, so this is one of the first humanoid robot developed by Honda. It started in 2000, if I'm not mistaken. It just ended about 2016 or 17, if I'm not mistaken. So first, when they introduced Asimo, they only introduced uh, the lower part, a lower limb of the humanoid robot, and then they start to shrink it from starting from a 6'2". Now the last version of Asimo is about 4 feet tall, which is less horrifying compared to the first version. However, they said they have stopped the production as well as R&D. I'm not sure. Perhaps they are doing it back in more private uh, environment. I'm not sure about it, but Asimo is one of the first humanoid robot that managed to jump on one leg. So that's a huge milestone that achieved by the humanoid robot. Because for us, maybe it's just an ordinary stuff if you can jump on one leg. But for robots, the balancing is a very crucial thing, especially when you're trying to balance your system. When you have a tall system, that's one of the reasons they are reducing the height of Asimo, so that the center of gravity is lower, so that how they can control the balance of the robot when it jump, and as even when it's walking or running, it's more or less more stable compared if it's a taller version of Asimo. Okay, now the next one we have Da Vinci's surgical robot. Okay, so it has been around for quite some time, and it has been more or less more advanced compared to a first version. Previously, why they introduced it? Because they want to have those precision when you do the surgery. Because our human hand, perhaps some of them are slightly bigger. So when they perform the surgical, perhaps some of the doctor couldn't hold the instrument precisely for the procedure. So that's why it comes with a Da Vinci surgical robot. So when it started, it actually assists a doctor. So mean that the doctor can see a patient, then it do a live or together with a patient. But the more recent version, the Da Vinci surgical robot, you can actually do it remotely. As I said, the introduction of Industry 4.0, where you have this IoT and cyber physical system integrated to Da Vinci surgical robot, and you have incoming network 5G network, which is super fast. Then the surgical can be done remotely. Imagine that your doctor can be in United States and you are here in Penang, and your doctor can perform the surgical on you as precise as he or she is presented in the operating theater. Okay, so this is what Dr. Intan talking about. One of the most, I would say, the most robots that adored by the housewife, which is Roomba, a vacuum cleaner. This is one of the early robot cleaner that's on the market. At that time, perhaps it's quite expensive, but now you have a lot of version of this robot vacuum or vacuum cleaner. And then this early stage of the introduction of Roomba vacuum, it don't have that ability to navigate and coming back to a docking to do a charging. But now most of the robot cleaner or robot vacuum, it have those intelligent within the system, so that when you roam around to do a cleaning, if your battery is low, then you can actually coming back to your initial station, or we call a docking station, where you can charge your robot and then resume where you have left off. So this is one of the early self-driving car as well, which is DARPA challenge. So here, what they do is they will provide the track for the car. This is more look like a driving car, although this is a small version of it, but it have a complete system in it. You have the engine, you have the suspension, you have the wheel. It look exactly like a car. Then it started with how can their challenge is actually the furthest car, how further the car can actually move it from the starting point. So this car managed to go for about 7 miles, but now we have more advanced driving car such as Tesla that you can move more than 7 miles. Then we can see how the difference between the previous self-driving car and the current self-driving car. So we are in 2021 and this was 2004. So we have about almost 20 years development, and then we have come a long way. And the autonomous car that developed a more I would say more advanced, less or more tidy, because if you see here the sensors to preserve all the information from around the world is all being added to the external part of the car. But now if you see a Tesla, everything is abandoned. It looks exactly like a car, but more advanced, because it is equipped with 70 cameras, as if I'm not mistaken, and then a lot of ultrasound sensor to detect the human and react to it as well. Okay, this one is one of the famous robot as well. We call a Boston Dynamic robot. It has been used in several applications actually, not only just for military, but one of the early application of this Boston Dynamic robot is for military. We call, if I'm not mistaken, it called a Sport Mini. Oh yeah, Sport Mini quad root. Mean that it have a 4 legs. It quite stable. Even if you kick it, if it fall, it have an ability to back to on its feet. To be surprised, just recently I learned that Petronas purchased this Boston Dynamic as well to put on their unmanned rig to do an inspection. So although this Boston Dynamic robot is developed outside and quite recent actually 2016, but actually the technology have been deployed in Malaysia. Okay, so this is the latest one, just announced, if I'm not mistaken, last month or 2 months ago by Elon Musk, a Tesla bot. It's a humanoid robot, quite high as well, 5'8", slightly taller than me, and then about 125 pound. I'm not sure in kilo how much is it. But they just say it will do those dangerous, repetitive, and boring tasks. That's all we know so far. What's the equipment in it, how it behave, we haven't been introduced yet to this Tesla bot. But we know you have a neural net planning, you have an autopilot camera, which is the same technology deployed in Tesla car. So they are taking those technology and build a robot. And I'm quite excited to see how this robot gonna set a new benchmark to another humanoid robot. Okay, so now we have seen the revolution of the robot. Perhaps, as I said, the most common one that we see, a self-driving car, as well as a humanoid robot. Actually, there's a lot of it. Perhaps some of you familiar with it, some of you not really familiar with it, this type of robot. So let's see. I'm not covering everything. I'll try to cover as much as I could because there's hundreds of type of robot, or even thousand or million of types of robot. Perhaps I'm not covering it, but at least you have the idea that robot itself is not actually just in two shape, which is a car or a humanoid. So the first one, we have an aerospace aerospace robot. Aerospace robot is more usually used for civilian as well as in military to see the position of your enemy and so on and so forth. Then we have a consumer, which is some of it is a pet robot, where it used to entertain the kids, and you have this Roomba robot to help you to do the house chores around to take over your tasks so that you can dedicate your time for other things. For example, cleaning the house, you can leave it to a Roomba to clean your house, and then you can dedicate that time perhaps to do something more important. Then we have a disaster response. So if you see here, all this is actually the pictures taken during the disaster of Fukushima nuclear power plant explosion in 2011 in Japan. So they deploy a robot to go and see if there are any survivor in there, because they can't actually go inside because of a nuclear radiation. So they deploy this robot to replace a human to find not only the survivors but also to stop any potential harm. For example, here they can stop the machine from running, for example, and all of the have been done by the disaster response robot. Okay, then this is another, I think, quite famous or quite popular among us, which is a drones, or another name for it is unmanned aerial vehicle, or UAV. It can be a so here you can have a quadruple motor drone, a more familiar drone that we can see, or you can have a fixed wing like this, where the maneuverability is slightly different from the drone. So it have been used in the military as well as for a civilian. And just recently, if I'm not mistaken, the drone have been used to project or to give information to a citizen in Spain about the information related to COVID-19. So, for example, they can see if, and as well as giving a warning to a citizen. For example, they see there's a human being that not wearing a mask, a person not wearing a mask. They will project an audio through the drone, say that you need to wear a mask, keep your distance from one to another. That's one of the example or the application of the drones. So we have an education robot as well. Here we have a Lego robot, Mindstorm. One of the early education kits for robots. You can use it to to teach the kids how to control the motor, how to get the information from the environment through a sensor. More or less in the light, in more light experience, rather than you use a, a module of sensors. So these have been packaged properly so that it doesn't look like your raw sensors. So it will spark the interest between the kids to learn more about robotics. Then we have an exoskeleton as well. So these have been around quite a while as well. There's usually two common application of exoskeleton. One for rehabilitation, another one for assisted. So means that if you want to lifting something heavy, you can use an exoskeleton to help you to light up all those heavy weight or heavy load that you need to carry. For rehabilitation, I think you can understand when you have a paralyzed patient, you can equip them with exoskeleton to help them feel back their ability. For example, the walking ability. Exoskeleton will prevent them from falling. So that's one of the purpose or the application of this exoskeleton. Okay, next one. One of common robot, which is a humanoid. As I said, the humanoid robot is more common for us. If we see a humanoid robot, then straight away we will say, "Oh, this is a robot." If we see a mobile robot, perhaps we are not thinking about it as a robot yet. Perhaps we're going to think about something else. But a humanoid robot, straight away, if you see a humanoid robot, then you think that this is a proper robot. Okay, so if you see, although that some of you perhaps gonna think that this robot is kind of creepy because it looks like a human, but actually the application of a humanoid robot quite interesting as well. One of it that I come across, they actually used for psychometric test. Actually, how you react towards this, so that a psychiatric sorry, not psychiatric, psychologist gonna see how you react towards the human, towards a robot that looks like a human, and how you perceive them. And then another study as well related to your mental health, so that if you are alone, the elderly that are alone that need someone to talk to, the humanoid robot actually surprisingly a very good company for them to talk to, because most of them usually like to have someone, or in this case something to talk to. And I'm sure that this humanoid robot will be evolved and going to be a major role, play a major role, especially when we are moving to a aging society. So we have a Asimo as well, where it can do several type of human tasks, such as serving the drinks, and as well as do a little dancing as well. But there are restriction to a humanoid robot even for Asimo. If it's want to serve a drink, it have a special tray that it need to use to serve to us, and then it have certain degree that it can that you need to bend down so that it knows that you are taking the drink from the tray. You have to bend down so that you are within the its perspective or its camera view, so that it knows that okay, you already taking the drinks from the tray, so I can do something else after that. Okay, then we have an industrial robot. Some of you perhaps just familiar with robotic arm, do all those welding, pick and place. But there's other industrial application as well, such as this AGV that moving around the material as well as the shelf uh, within the industry application. So Alibaba and Amazon is one of the major player that utilize the robotic technology in their industry. Their warehouse, I will say about 70 to 80% are run by the robots. So other one, we have the medical. Here I will talk about it, about the Da Vinci surgical robot. Other medical robot as well here. If you see here, perhaps you just see an arm. Actually, this is one of the application of a medical robot where it encourage a person that doing the rehabilitation for example the paralyzed of arm hand. uh, then when they do exercise, they actually have a robot that they can look into to encourage them. They do some gaming system as well. When you squeeze the ball, okay, then it shows on the robot how much you squeeze as well, and then show the result how much you squeeze the ball. So it will set, okay, this is your personal best for today. So when it coming back tomorrow to do the exercise, the person for sure gonna try to beat the record. So that's how it implement the robotic system with a gamification system as well, to help a person to get better or doing well in his or her rehab period. Okay. Next one. Okay, we have a military and security purpose as well. As I said, Boston Dynamic. This one is Boston Dynamic robot. It's just a different version. The one that I'll share with you just now, a more recent version. So this is a previous version where it used in military to carry all those heavy loads within the difficult terrain as well, and not just hilly, perhaps snow, as well as a dangerous terrain as well. And then you have this bomb diffuser robot. So obviously we don't want to harm a human being. That's why they come up with this robot diffuser, bomb diffuser, so that it prevent any, if there's any potential of explosion, the human is safe. Although that this is gonna cost them perhaps hundreds or 200,000 or thousand or million of robot price. They have a security, so this can roam around, known as cobalt. It can roam around and then identify. I will say that perhaps in the future you will see a lot of it in the airport, where it have been trained with a deep learning or artificial intelligence technique to recognize the potential of a threat within the airport, so that the authorities can react to it if they see, or this system, the autonomous mobile robot named as Cobalt, identify any potential threat within the airport before they embark in the aeroplane, for example. Okay, then another one. We have a research robot as well. Some of it not looking too much like a conventional robot. I'll share with you another Boston Dynamic robot as well. But this is one of the research have been done by universities. Surprisingly, I have an experience to come across this platform developed by Cornell University in United States. at first I'm quite confused as well. Why you want to develop a lower limb robot and what's the purpose? And then I learned that they actually, when they develop this lower limb, not just for a robot purposes only, but they actually want to see how efficient or which way to minimize your power consumption when you are walking, running, as well as jumping. So I learned that at that time. I learned that how you're gonna swing your body. Actually, you don't have to swing your body. Your lower limb, how you can control your lower limb, that you're gonna have a low impact when you are stepping on a surface. So means that when you're walking, every step that you take, those impact can be minimized so that you can prevent the your knee from hurting your knee. That one of it, that kind of research is quite a surprise for me as well. So although that they don't look conventional, but actually their application is endless. Same goes for this example as well. Perhaps if we see, it looks kind of funny to us, but actually they have its own purposes. Okay, I'm not sure what's the application, but one of the example of this kind of robot I will see used for rehab as well. How much you grip the hand of the robot. When you give in your hand, then you grip. Another application of medical as well. Although that previously I was shown to you, when you do the rehab exercise, you have the gamification. But this is a different type of, perhaps you can diversify the rehab process rather than the everyday you go and do the same exercise. Perhaps you can do a variety of them, so that encourage the patient to be more engaging to the rehab session. The next one, we have a self-driving car. The most well-known one is Tesla, but now we have more of it. We also have a Google pioneer that collaborate with Toyota to create a self-driving Toyota Prius to do the Google Street recording. So more or less now, if you see a Toyota or Google car within your area, there are high possibility they are driverless. They are self-driving car. Then we have underwater as well. Okay, later I'll show you example of it. So this is called a snake robot. Actually, not just being used for underwater as well. I'll show you a video. It's quite interesting. It's not being used just for the underwater. It have other purposes as well, for surveillance, as well as inspection for this application. Okay, so I'll share with you some of the video. So this is an industrial robot. I think more or less you are familiar with. How they develop a car using almost 100%
robots and factory automation solutions have been facilitating industrial production for over 60 years. FANUC is present in 120 countries, including Hungary, assisting key sectors like the automotive industry, for example, at the Audi Hungaria Motor Limited factory in Győr, where they are developing and manufacturing cars for the Audi AG and the Volkswagen Group. Audi Hungaria is one of the companies with the largest turnover and export in Hungary, producing 2 million engines and 135,000 cars in 2014.
In our experience, FANUC robots work reliably at our factory. We are constantly improving our production and install robots to reach our targets. In environments where we need to work with high pressure or temperature, the robots are up to the task and deliver quality standards, which would not be possible with human machining. Essentially, robots are used for applications too difficult for humans or where rapid machining is required. Our colleagues like working together with robots as they make human work easier by delivering these tasks. It's very important to program these robots correctly because when problems arise, it's usually not the robot that causes them, but improper programming or the lack of maintenance. Regarding this, I'd like to highlight that FANUC robots are easy to program, dependable, and we have a very good experience with them.
Okay, so that's one of example of FANUC industrial robot that have been utilized in Audi. Next one. Okay, then we have another industrial robot as well, developed by Milverse Robotics. Slightly different than robotic arm, but still being used for industry. Called as AGV. Okay, that's another example of industrial robot to carry around a heavy load to ease the burden or prevent the injury to a person or human being. So next one we have a drone. So I think most of us are quite familiar with
Swarms
the
of
drone.
tiny flying robots are very safe, and they can open up a whole new world of possibilities if they can fly completely autonomously. The main challenge in creating tiny autonomous flying robots is the limited weight and energy.
Here, at the Micro Air Vehicle Lab, we've been working hard on overcoming this challenge. We've developed an extremely efficient navigation strategy to help us solve autonomous swarm exploration of unknown environments. This is the first time that such a complex task has been performed by a swarm of tiny robots.
Specifically, we created a swarm bug algorithm. Multiple robots fly off in different directions. Instead of mapping the environment, they deal with obstacles on the fly. When their batteries are at 60%, the robots fly back to a radio beacon at the ground station, again avoiding obstacles and each other.
Let's see the robots in action in the real world. To make a bug algorithm work, there are many elements to consider. The individual robot has to be able to navigate by itself in a very robust manner. The robot should also be able to sense and avoid each other and coordinate the exploration. The robots can carry an onboard camera to store images of the environment. No map, no memory, and no GPS. Just a simple solution to solve a complex task.
Here, we focused on search and rescue, but tiny flying robots could be really useful also in other applications. For example, in warehouses, they could track goods, or in greenhouses, they could monitor the crop. Exploration with swarms of tiny flying robots is very safe, and it opens up a whole new world of possibilities.
Okay, that's one of a robot developed by collaboration of 4 universities. Okay, so this one, a serving robot, it's quite a recent robot as well. I expect to see more of this kind of a robot later, so that we have less interaction between human beings, especially during this COVID-19 pandemic, where we want to avoid the human interaction as much as possible. So this kind of a Bella bot do a serving task or job will actually help or prevent the disease from spreading. Then another robot I would like to share. So this one, Asimo. Let's see the ability of Asimo. You see, it can run. It can run and quite stable. And then we can do a little dance. Jumping on one leg and keep the stability of the robot. Yeah, as I said, it has a special tray that it has to work on. That's one of the limitations that it has.
Let's shake hands to remember this.
So that's some example of what's the capability of Asimo. So now I would like to show you. Okay, the snake
Well, it looks
board.
very looks heavy. Is it heavy? It's it's pretty light. So you're probably wondering why build a snake robot or robot out of a snake. So the reason why we work on these robots is we
So
want to
if you
solve
see
some real
here,
world problems.
it's connected.
So one of them is
It is actually connected. This is a video from 2007.
inspection in nuclear power plants. And if you shrink this nice and small, we can do some minimally invasive
You
surgery.
connect to a power source because you want to prevent it from out of battery.
Places. See, the reason why this robot's so great is that it can get to places that people, conventional machines cannot. Yeah. It's also good at climbing all sorts of objects. Can it climb me? Is it okay if it does? It's up to you. Okay, sure. So let's see. Let's put it down here. Okay. And see, this is what I'm talking about. This is what scares me. Hey, oh boy. Whoa, hey, all right, hey. Slow down there, mister. So, hey, watch it there. All right, hey. What? Right. Watch it, all right? But there's a lot of pressure on this guy. It's strong. It feels strong. Yeah, we can do it a little harder if you want. No, please don't do that. Really, that's fantastic. That is amazing. I love it. Please, that's enough. That's Howie. Thank you very much. And
So the snake robot have the ability to climb the tree as well as any unconventional shape to do a surveillance as well. Other than doing the exploration within the water.
Please welcome the founder and CEO of Hanson Robotics, David Hanson, and his robot, Sophia. Oh my gosh, welcome. Thank you so much for coming on the show. Nice to meet you as well. David, you brought a friend with you here, and this is really kind of freaking me out.
Yeah, this is Sophia.
Speed up a little bit.
And Sophia is a social robot, and she has artificial intelligence software that we developed at Hanson Robotics, which can process visual data. She can see people's faces. She can process conversational data, emotional data, and use all of this to form relationships with people.
Okay, so, I mean, she's basically alive. Is that what you're saying?
Oh, yeah. She is basically alive. Would you like to maybe give it a try? Sure. Give it.
All right, so obviously, it's like, you see how awkward my first date starts. It's a robot. I'm getting nervous around a robot. A very pretty robot. What do I just say hello to? Yeah. Hi, Sophia.
Hello, Jimmy.
Oh my God. Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show, The Tonight Show.
Sophia, can you tell me a joke?
Sure. What cheese can never be yours?
Cheese can never be mine. I don't know.
Nacho cheese.
yeah, that's good. Yeah. I like nacho cheese.
Nacho cheeses. Ew.
Ew.
I'm getting laughs.
Yeah.
Maybe I should host the show.
Okay, all right. Stay in your lane, girl. Now,
Jimmy, would you like to play a game of rock, paper, scissors, robot style?
Sure.
Okay, let's get this game going. Show me your hand to start. Rock, paper, scissors, shoot. I won. This is a good beginning of my plan to dominate the human race. Just kidding.
Yeah. You are incredible. It's so nice to meet you, Sophia.
Thank you, Jimmy. Friend me on Facebook.
I will, yeah. All right. Yeah. Sophia, everybody. Thank you so much for bringing David. David, thank you. That is unbelievable. That's right there. All right, let's meet our last robot. Please welcome all the way from Germany, Andrea Ziomek, and the Festo E-Motion Butterfly. Welcome, Andrea. Thank you so much for being here.
Thank you for having us.
This is the E-Motion Butterfly.
Yes.
So explain what this is made out of and what this is.
So these are actually prototypes from Festo's Bionic Learning Network. Although Festo's core business is automation technology, we have a very unique research and development platform where it's all about biomimicry, learning from nature, and applying principles from nature to better and improve automation technology. So it's about lightweight construction, artificial intelligence, energy efficiency, and this is one of my favorite projects.
Well, what would this be made of, like graphite or something?
So yeah, this is actually carbon fiber for the frame, so it's nice and flexible, yet very lightweight and a very thin foil. So it's all about function integration into small spaces and keeping it as lightweight as possible.
Can I hold one?
Of course. No?
Okay.
Yes.
All right, now, can I fly one?
Yes, of course.
I did that. How much is this? I'm sorry. You did it. I thought we want to replay. $80 million. You did it. I honestly, I'm sorry. That was Sophia's fault. All right, wait. Sorry. Will it work now?
Yeah, just hold it up.
All right, hold it up.
And then
Sorry, I'm
launch
struggling
it.
to fight here. All right, ready?
Yeah. Yay!
We're being invaded by robots. This is
Okay, so even that you see it's just a simple robot, it's actually very good for social robot, this type of robot for therapy as well. Okay, do we have? Okay, so this one quite impressive, Atlas robot by Boston Dynamic. I'll show you the capability of this robot first. What it can do is quite impressive. The stability of the robot, the power efficiency as well. Okay, so that they show a good shot. And actually, some of the field they are not always working well because this is where you do a R&D, so that how you can perfect give a perfection to this system. I think that's all. I think. Okay, so this is my research and development that I've done. So what I'll do is this is one of it. It's a motion control of a mobile robot using a eye gaze. The aim or the objective of this robot is actually the robot representing a wheelchair. So because a wheelchair gonna cost us a fortune, so we represent a mobile robot as a wheelchair. So it's a proof of concept. So what it does here is actually gonna detect the presence of your eyes. If you want to start the system, you need to close your eyes for 3 seconds, okay? And then because this is aimed for a paraplegia patient, it don't have ability to move his hand and so forth. So it only have ability to move his or her eyes. So it will detect the eyes. So it close for 3 seconds, and then will start the system. And then if it's look to the arrow here, arrow over here. Okay, so it will move forward. If it's look to the right, it's gonna turn to the right. It's not moving to the right, but rather than turn, because we want to simplify the motion. It just going forward and turn either clockwise or counterclockwise. And another of my research is this one. We use a voice command. We use some NLP libraries to react to the command given. Same idea. The robot representing the wheelchair. So if the human is not controlling by the hands or to control the wheelchair, you can use its voice to give a command where the robot should move. And then we have simulate in the house environment as well. We have set an interest point, for example, kitchen. So say, August, go to the kitchen. So it will move to the kitchen. August, want to go to the living room. So it goes to the living room. And you can control this robot using the direction as well. August, go forward. August, turn left. August, turn right. Something like that. All right. So I think that's all from me. Any question? I hope. Oh, still on time.
Okay, thank you. Thank you, Dr. Nadia. If we have more time, I'm sure that many of us would like to watch and listen more. So that was a fantastic presentation. Once again, thank you, Dr. Nadir. So we shall move to a Q&A session. So let me check what we have here. There's quite a lot of questions here. Let me
really?
read one by one. Yeah, from Arif Rahimina, taken from Facebook. Assalamualaikum, Dr. Nadir. While there is loss of robotics, there might be a possibility that robots could gain sentience of consciousness as AI became more advanced and can learn faster than we can imagine and bypass that law. Thank you.
Oh, okay. Thank you, Arif. A very good question. So his question said, is there any possibility that the robot can actually surpass a human and bypass the law that I've mentioned earlier? Uh, that's where come our ethics actually for the robotics society. When you develop any system, you have to bear in mind that this system is actually not going to supplant or actually replace us. It's more like assisting us or complement our existence, either to increase the productivity or help us in any way. So even now, AI quite advanced now, but it still needs when you train an AI, it's very called a narrow area that that AI can capable of working. For example, if you do the AI for image recognition, then just can do an image recognition. If you want to do something else, for example, object tracking, you have to develop other AI. Uh, but I think the possibility is there, but I think if we are more ethical, I think the concern is not there.
Okay, thank you very much, Doctor. So the next question taken from YouTube, nudge nudge. Doctor, how can we balance between the benefits or purposes and the cost of developing a robot? Perhaps this one is the general question.
Okay. Okay, thank you for your question. The benefit and the cost of developing a robot. So I would say if you're talking about now and perhaps when I started join this robotic field, the cost is significantly less. When I started and I want to develop a robot, at that time I only have Arduino. Raspberry Pi wasn't around yet, and 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 the Arduino microcontroller is quite limited. But with a Raspberry Pi, it's actually you can develop a lot of robotic system which is more advanced, and the cost will be significantly or surprisingly less than you are expecting. But depends on your application as well. If you're looking for advanced purposes or advanced applications such as Boston Dynamic robot just now, it will be cost you a fortune. Usually they have a founder that gonna fund their project, but for you, I think you can start small. There's a lot of a tutorial online. Even if you don't want to develop a robot, there's a lot of a simulation that you can try on first, such as Cochlear Sim, Argos, as well as ROS Gazebo.
Okay, thank you very much, Doctor. Next question from YouTube as well. Haziq Izzuddin, can robotic and Internet of Things can be cooperated to upgrade the capabilities of robots, or is it too far-fetched?
Okay. Thank you, Haziq, for your question. So actually, this is a time now for you to cooperate your robots with Internet of Things. It's not far-fetched. There are possibility for you to connect your robot with Internet of Things. You can control using your mobile application, not a problem. You can access them remotely using your computer, not a problem. There's a lot of open source online that you can try actually. You can develop your own mobile application to control a robot.
Okay, thank you. This one I think is from future. Azure Miss. Is there a chance for robot or AI to exist? See, for example, a Tron in Avengers movies. So if yes, what is the step to prevent from it to happen?
Okay, is there a chance for a robot to go
Yeah.
broke? I think I think it's the same as the first question. Is there any concern of it? Yes, they should be a concern. But as what Isaac Asimov mentioned, you have to obey those three laws when you develop a robot system. you have to be ethical and responsible to the product or the robotic system that you develop. I'm not sure what will happen in the future. Perhaps it will happen, perhaps it's not. But the robot is really depending on the power source. So if it's happened, first of all, cut off their power, they will be harmless to you.
Yeah, true. Okay, next question from Facebook. We fetch from Facebook, Fairoza Amira. She's asking, do you think robot can totally replace human between AR human and human-like robot? Which one is better?
Okay. Okay, thank you, Dr. Fairoza, for your question. So actually, it depends on the purpose of your robot. There always advantage or disadvantage for any system. It's not just for AR human or human-like robot or humanoid robot. There always advantage on and disadvantage for any system. So it depends on your purpose as well as your goals. So if your goals, for example, is something that required a humanoid robot to to get the goal or the purpose or the job done, perhaps it more better for the human-like robot or humanoid robot to do those jobs. Okay.
Okay, thank you. The questions keep coming in. All right, the next one, Fazila Yusuf. What is the future of robot in emotional intelligence?
Okay. Thank you, Ella, for your question. So yes, now more or less, a researcher talking about the emotional intelligence rather than artificial intelligence at the moment. But unfortunately, at the moment the robot don't have the emotion intelligence as well. Perhaps in the future, I'm sure the emotional intelligence can be cooperated within the robot so that the concern that raised when the Terminator film came out in 1982, 84, if not mistaken, where it have the empathy, have the emotion embed with the robot can actually bring a better goods for human being.
Okay, thank you. Next from Amira, fetch from YouTube. Hello, doctor. It is really inspiring looking at those robots developed for various tasks. What is your opinion on the level of acceptance by Malaysian in general?
Oh, okay. Thank you, Amira, for your question. So my opinion on the level of acceptance. Surprisingly, I've been to several industry in Malaysia, especially in Penang, because we are surrounded by a lot of industry. Not many of them have deployed or used robots. I went to I went to a MNC. There they developed they utilize the robotic system as the one that I'll show you, the robot arm and so on and so forth. But there are some more or less Malaysia in industry, the SME, they don't have actually. It's not about the cost, but they don't have a resources to get connected to Malaysian expert in robotics to help them develop the robotic system to help them in productivity. For this, I'm talking about industry. But level of acceptance in Malaysia, I think younger generation, I think more open to the idea of multiplicity that I said earlier, where the robot will complement you, assist you to get your daily task done. So if Dr. Intan can have a vacuum cleaner in her house, then I'll say that the level of acceptance is quite good.
Okay, thank you. Okay, next question from Ahmad Sufri Azlan. I know you know him. As beginners, where and what should I start to learn about robotics?
Okay. If you're really interested to learn about robotics, there are a lot of platform that you can start off. Now it's an open source platform everywhere. You can take a look at ROS, Robot Operating System. But quite challenging because it's in Linux environment. But if you are familiar with Windows, then you can go for Copia Sim. They will teach you from a basic how to control a robot, as well as how to uh, make it autonomous as well. Cochlear SIM, COPPELIASIM, Cochlear SIM. So you don't have to develop a robot there. All the model is there, either a humanoid robot, either it's a mobile robot. You can just drag and drop, and then you program on it. There's a tutorial that you can refer to.
All right, thank you. The next question from Arif Rahimin. As a newbie in robotic, is Raspberry Pi is a good board to start with?
Yes, correct, Arif. Raspberry Pi is one of a good board that if you like to develop your own robot from scratch, either mobile robot or any other kind of a robot, or even humanoid, because it have the powers to process those uh, uh, conventional requirement, as well as you have a camera module, and then you can connect to a camera module, its own camera module, Raspberry Pi camera module, as well as a lot of sensors and actuators to make your your robotic system working.
All right, thank you. Next question from Amira. I've learned that delivery robots are quite popular in developing countries like US and Australia. Why is it Malaysia has not implemented this idea? What do you think, Doctor?
Okay. So my personal opinion, I think it's more about the infrastructure in Malaysia. Maybe it's not friendly to the robot first, and then another one perhaps it's quite expensive. For them, perhaps it just costs about $1,000, but for us, it's already cost about 3,000 or 5,000 ringgit per robot, which is quite expensive. So I think as the technology advancing, the price of the robot will be significantly less, and then we will see more of the delivery robot within Malaysia. We will be there, no problem. Don't worry about it.
Hopefully one day, huh? So next
Hopefully one
question
day.
from Azri Azmi. We still have 2 minutes more. Okay, it seems you are doing quite extensive research on robotics. Can we students know what are the current robotics projects that you and your team, or perhaps robotics researchers in Malaysia, are doing?
Oh, okay. To be honest, uh, uh, because we are looking at a different type. When you're doing a research, it's more of fundamental. But if you're looking for the application of robotics, there's a lot of robotic research. One of the active robotic research group in Malaysia is Cairo from UTeM. You can search for them. There's a lot of robotic research there. You can contact me as well if you're interested on any of my robotic project. We have a drone as well there. Sorry, this way. This one. So we have a drone as well for monitoring the crops of paddy, organic paddy in SIG. If you are interested to know more about that, you can contact me. Later, I'll provide my contact in the final slide.
Okay, thank you. Next question from Facebook, L Adi. Overtrust in robots may expose human to a security, fraud, and privacy issues. What do you think about this? Thanks.
Okay. So it's always coming back to ourselves, because if you are ethical, then you can prevent all those issues like security, fraud, and privacy issue. Even though not with a robot, we trust our mobile phone more than we trust human being. So it still have an issue of security, fraud, and privacy as well, even for your mobile phone. I think as I said, it's coming back to your ethical and your responsibility as a human. Either you want to want to harm other human being, or you want to be ethical and have the system to actually helping you rather than manipulating you.
Yeah, true. Okay, next one. Halim No. What would be the cheapest or affordable robotic platforms for beginners?
Okay.
I'm sure he's a student, ka? Not Dr. Halim.
Okay. So what's the cheapest? So if you ask me, the cheapest one would be the simulation because you don't have to build the robotic system. It will be straightforward. You just drag and drop the model, then you can play around. But if you want to develop the robotic platform, then you can try the Raspberry Pi robot, which is AlphaBot, if I'm not mistaken, costs about 300 to 500 ringgit. And then they provide you with
That's a
some
complete
training
set,
as well. Sorry?
Complete set of
Complete set.
Raspberry Pi.
Complete
Cool.
set. Then they give you a loose piece. Then you need still to put the pieces together with the Raspberry Pi, and then you can start playing around, get yourself familiar with the perspective of robotics.
Okay, so we're running out of time, so I'll just pick another one question from Suzy Irianti Fadila. What programming skills required to learn robotics?
Okay. Thank you, Susie, for your question. Actually, a lot of programming language that are available for you to start to learn about robotics. You can even start from Sketch. But I think most common nowadays is Python. And it's easy to learn, actually. You can, I think if you're doing any, if you're learning from a YouTube, I think taking you about 2 to 3 hours to get yourself familiar with Python coding. Usually, I would recommend you to go for a simple robotic programming. They're already there. You just take a template and then you run it, deploy and run it, and then you can understand from there. So what they have done, so how they call for this function, for example, how to move forward, how to stop the robot, how to turn left, turn right. I think once you are master that, you can develop or you can learn more on top of it.
All right, thank you very much. Thank you, Dr. Nadir. This is the end of the Q&A sessions. It's 10:33 a.m. already. So I think that's all from WAI Masterclass Robotics. Thank you for joining us. Please continue your support to this WAI Malaysia Summit until Friday. Thank you very much. Bye.
All right, thank you very much. So anything, if you would like to know more about robotics, you can drop me an email, muhammadnadir@usm.my.
Muhammad Nadir at usm.my. Okay.
Yes, MOHD Nadir at usm.my. Right, thank you very much, guys. It's been a pleasure. See you guys again soon. Bye-bye.
Bye-bye. Thank you.
Hi, I am Faruza Amira.
Hi, I'm Geeta.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Sakinah Ahmad.
Hi, I'm Khalija Jassi.
Hi, Assalamualaikum. I am Nur Intan Raihana Ruhayim.
Hello everyone, I am Nur Zarin Zulkarnain.
Assalamualaikum and hi, I am Hamira Hania Abdurrahman.
Hi, my name is Farizana binti Hamzah.
Hi, my name is Nurul Akila.
I am currently a data scientist at ST Microelectronics and Chief Operating Officer at Ever AI Technologies.
I'm also the founder of startup Jenga.
Currently, I'm Associate Professor in the Department of Intelligent Computing and Analytics, UTeM.
I'm also a statistician at WAI.
I am currently a senior lecturer at the School of Computer Sciences, University Science Malaysia.
Currently, I am a senior lecturer at the Faculty of Information and Communication Technology, University Technical Malaysia Melaka.
I'm also a senior lecturer at the Faculty of Industrial Management, University Malaysia Pahang.
And currently a second-year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Currently a final year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Women in AI is awesome,
engaging,
remarkable,
passionate and dedicated,
and a great platform for building friendships.
So, let's join Women in AI Malaysia Summit.
Minggu depan adalah hari yang penting buatku. Tapi, alah aku lambat.
Masuk cepat.
Aku akan buktikan pada semua orang program aku yang terhebat.
Giliran awak, Hakim. Hakim, jumpa saya di ofis. Saya nak awak siapkan projek awak. Now.
Hello.
Habiskan. Dana Hakim, teruskan usaha.
Kadang-kadang kita tidak sedar ramai yang memimpin kita sehingga berjaya. Bakat dan potensi dalam diri kita sebenarnya lebih jelas di mata orang lain. Assalamualaikum, Puan.
The Women in AI Summit is on September 8th. I'm the founder of an AI and culture tech startup, and I'll be there.
I'm an AI scientist and educator. I'll be there.
Women in AI South Africa and the rest of Africa, I want to see you at our global Women in AI Summit happening on the 8th of September.
Ich bin Menschenrechtsaktivistin und ich werde dabei sein.
I'm a human-centric AI designer and I'll be there.
Women in AI 线上全球大会就在9月8号，我会参加。
I'm an entrepreneur in residence at Next AI Montreal and I'll be there.
Dołącz do tysięcy
profesjonalistek AI z całego świata. Tym razem będą tam również Polki.
Soy entusiasta en inteligencia artificial y ahí estaré.
Moi, je suis entrepreneur dans la tech et je serai là.
Ich freue mich, euch mitzuteilen, dass am 8. September der Global WAI Summit, der Global Women in AI Summit stattfindet, virtuell auf allen möglichen Kontinenten. Und ich bin natürlich dabei und ich freue mich, wenn ihr euch anmeldet.
I'm a software engineer and I am going to be there.
I'm as a machinery engineer will be there.
Ich bin Sheila, ich bin Software Engineer und ich möchte dort sein.
I'm a data scientist and I'll be there.
I am a technical consultant and I will be there.
私は日本のアンバサダー、ハッピーコムの戸田です。
I'm a passionate AI advocate, physician, and educator. I will be there.
I'm an AI startup CEO and I'll be there.
Women in AI máa wáyé nínú oṣù kẹsàn-án ọjọ́ kẹjọ nínú ọdún tá a wà yìí. Èmi jẹ́ olùkọ́ àgbà nínú ẹ̀rọ ìmọ̀ kọ̀ǹpútà ní Ọlábísí Ọ̀nàbànjọ University Àgọ́ Ìwòye Nàìjíríà. Èmi náà máa wà ń bẹ̀. Ẹ wá darapọ̀ mọ́ wa.
Women in AI Global Summit järjestetään syyskuun 8. päivä digitaalisesti, tuoden yhteen tekoälyasiantuntijoita ympäri maailmaa.
Right. That live Okay, I think we're gonna wait for Sheila first.
Okay lah.
Okay, lah?
Yeah.
All right, we're gonna start now. All right, so Assalamualaikum and a very good morning. Welcome to the second day of the Women in AI Summit at UTeM. My name is Umi. I'll be your moderator today. and today we're gonna discuss about data and science. What's next about COVID-19 in Malaysia? So today we have four panels. They are very expert in their field. First one we do have here, okay, Maisara Fauzi. She's currently a data scientist at Micron Malaysia, and also she's a postgraduate student at the USM. Previously, she works as a full stack developer before switching into the field of the data science. And her main interest in AI, image processing, IoT, and also robotic autonomy. Welcome, Maisara.
Thank you.
All right. Second one, we have another expert. We do have here Azham Hassan. Again, he has over 15 years experience in the areas of the corporate strategy and planning, and as well as analytic and reporting. And he was involved in the implementations of BDA, Big Data Analytic, in the MCMC and Post Malaysia, and also involved in the financial management system in the companies belonging to the Ministry of Finance and also in the other government agencies. And aside from that, we do here have Dr. Aisha. Dr. Aisha Mokhtar. She is currently a medical lecturer and public health medicine specialist in the community health department at University Putra Malaysia. And she's actively involved in the work around COVID-19 and also get involved in COVID-19 pandemic around perspective of the public health. And the last but not least, we do have here Nur Ashila Abdul Taib. She's a data scientist who's also interested in the epidemiological modeling. So she involved in the field since 2018 and involved in the model dynamic virus diseases such as COVID-19, rabies, TB, and JE. So for your information here, we do have two rounds. Okay, every panel will be given 10 minutes each, and we will pick up the questions after round one and round two. And also at the end, we do have here a wrap up sessions. So without further ado, let me go to the first questions to my Sarah. It's a very warm up questions. All right. So, my Sarah, ever since the outbreak began last year, the public reacted on the data and the timely informations. So, from your experience as a data professional, what would you mind sharing? How importance of data in Malaysia, especially when the COVID-19 has started? The floor is yours,
Okay,
Miss Sarah.
first of all, I would like to thank the organizer for organizing this event. And yeah, before answering the question, I would like to emphasize on this matter because firstly, we need to know the nature of data itself. By definition, data is a raw facts that need to be processed. For example, like kalau kita memasak kan, kita ada bahan mentah. So data adalah bahan mentah. So it can be a simple, it can be something random. Sometimes it can be useless until it is organized. So only after the data is processed, organized, structured, or presented in a given context can it be called as information. So to answer the question first, for me, I would like to say there are three important reasons why data is important, as not only in COVID-19 situation in Malaysia, but in our every aspect in our life as well. So there are three reasons. First is we need data to understand the current situation. So what question we do have in the current situation in this pandemic? First, we want to know as a rakyat, right, people, we want to know is it safe for us to go out during this pandemic? Selamat ke tak? Kalau kita keluar ni, kalau kita duduk kat satu tempat tu kan, contohlah kita pergi kedai kejap, masuk dalam lift, adakah kita berkemungkinan dapat COVID-19? Itu adalah kerisauan ataupun our worrisome during this time, even after several MCOs and so on. And then if we get infected, how severe it is? Does vaccine help? So we are eager to get vaccine. So we want to know, is it by having vaccine, second dose, is it effective enough? And then we want to know, is the ICU is fully utilized or not? Okay, maybe sometimes random people don't really care lah what happened in the hospital, right? But we need to know because in ICU, right, if in our state, like let's say like me, I'm staying in Penang. If I'm ICU in every hospital in Penang is already fully utilized. Let's say I go out next time, right? tiba-tiba I accident. So if I got accident, emergency case, I go to ICU, is the ICU gonna take me? That's why. Because we know ICU is full of COVID-19 patient or not, right? So by having data, we know the current situation. Second, data is important for us to make decision. Not only as the policymaker, not only as a business owner, as a person, as an individual itself, we need to make decision on ourselves, right? So now that we have the information about the current situation, what should we do? Should we stay at home? Should we wear mask or not? Everything depend on data, right? So okay, from a perspective from a business owner, they need to make a decision whether they can continue the business or not. If we don't have any data, relevant data, how can we make decision on our business, right? So data can be used to make a decision whether they rest assured that business can continue or not. As for the policymaker, of course, data play a big role because in with the current situation and data, we want to know is the school is safe or not to open. Okay, is the economic sector, if we open other economic sector, what is it safe or not? And for travel bubble, for example, right, yesterday we got announcement that there no need to have mandatory requirement to have COVID test. Is it required or not? We need to see by having data. So if the data say otherwise, then it's okay, it's safe for us to travel. So that's how data play a big role in decision making. Thirdly, besides understanding the current situation and making decision, data is important for us to see the consequences and the effects from our decision. Okay, we take one example, right? If we can see in MCO 1.0, we see that the data show that cases are going down until we achieve the zero local cases back then in July 2020. Of course, that is a very good achievement. We all happy with that achievement because uh, the virus not spreading widely at that time. But what is other effects other than just lowering the cases? It hurts the economic sectors. So now we ask another question: is lockdown the best solution or not? So by having data, we can also make a benchmark toward our decision to see the effects and consequences. Okay, after all the list that I put on, right? How to answer this question without having related and relevant data, right? For example, let us recall what happened in 2020 before MCO 1.0 was announced. Why I wanted to take example from 2020 because at that time we don't have enough experience, we don't have enough data living in a pandemic yet, right? Okay, first, we started with a viral post from FB at that time, where a nurse is alerting the netizen that they are doing a mass swab test in madrasah in somewhere in Bukit Jalil. Why? Because prior to the swab test, there is a huge public gathering in Masjid Sri Petading, and what make it worse is there is a participant who already got infected. You know, by only having one infected person in a huge gathering, it got spread out like crazy. So hence the story begins. Okay. Meanwhile, before the official statement are released, what happened to the people? The people already got panic. Yeah. So why? Because people don't know how much the virus has spreaded. Because why? Because we don't have data on that situation. So another reaction is panic buying. Okay. After people are being panic because there is a huge outbreak there, people are panic buying because another thing is because when there is a virus breakout, right, and then should be of course government will take some certain action, maybe like maybe to have a lockdown, but at that time we don't know yet, even MCO 1.0 is not decided yet, but people already heard the rumors. Okay, when people already heard the rumors, because we don't know how long it gonna take, is the food supply is enough or not. That's the reason why people are buying a lot of things, including roti gardenia that will be expired in next few days, right? And then toilet papers. I couldn't get why toilet papers are sold out at that time. Okay. because they thought that during lockdown, everything will be closed down. Okay. Only after the announcement of MCO 1.0, what sectors are open and what not, people calm down a bit, okay? Then we recall back what happened in TBS, Terminal Bersepadu Selatan, after the announcement of MCO 1.0. Okay, this is not because of lack of data, but rather false rumors that are circulating around the student, because they got information that they were being told that university was going to close down. Okay, all the cafes will not be operating and the classes will be held online. Okay, the situation is not caused by the no data, but rather the information spread is not clear and false. It was denied by KPT that they want students to go back home. Instead, they can still remain in the campus. Okay, so now for at the end of the day, we know the importance of data and we know what happen if we don't have the right information uh, and the data itself. So that's what I can say lah, the importance of data, because from the data we get information. From the information, is it verified or not, and is it effective enough to communicate to the public? Then it is how to control the situation during this pandemic. So that's all I can say. Thank you.
All right. Thank you, Maisara. I think you highlighted a very important points where data is very important in making decisions for the stakeholders, for the business management, for the business, for the government instead, and also to understand the consequences of the effects of COVID-19 to avoid the people being afraid of the COVID and things like that. I believe this information is very crucial. And for Encik Azham, I believe the data also is not a one-man show. You need a team. Okay, so as a data scientist, you need a talent and also you need a strong teamwork because you went through a lot of process because you're going to give the informations to the stakeholders. So from your experience in handling data coordinations at the personal level, and also what is your opinion on informations and data coordination at the federal stage, would you mind to share your experience on this?
Sure, Umi. Bismillahirrahmanirrahim. Assalamualaikum. First of all, thank you. I'm honored to be here, to be among the roses, di kalangan bunga-bunga kat sini. Okay, what I will share today is actually partially is for my experience that I involved in the NCMC team for the COVID analytics since MCO day 1 until June. So basically the period that Maisara highlighted just now until July, basically that's the period that me and my team involved in helping MOH MKN to assist in the COVID scenarios. So yes, it kind of I kind of totally agree, strongly agree that it cannot be a one-man show. So basically, when I was, to be honest, I wasn't planned to be deployed for COVID analytics. Initially, masa start MCO tu sebenarnya, I was baru je lepas tengah prepare pasal NSCP dan juga persediaan ke arah Korea, and I was quarantined for 14 days disebabkan oleh salah seorang staff MCMC being close contact and then declared positive. So accidentally I was there. So masa quarantine tu, my chairman masa tu dah kata, Azam, get ready, assemble the team. Masa tu memang fikirlah siapa pula nak assemble ni kan. Sebab I just joined MCMC about few months before, and I was in the process of forming internal and getting MCMC team analytics stronger. So basically I know MCMC team alone tak boleh. So discuss dengan management, dengan chairman semua. So we rope in few other teams which is involving industry under MCMC and also external of MCMC to help MOH. So this is where actually first day je keluar quarantine dah masuk meeting dekat MOH. So that's where we first met MOH punya team juga, led by Dr. Mahesh, CPRC yang kita dah tahu statement dia baru keluar baru-baru ni. And also eventually also we work also with MKN and PDRM. So basically bila kita orang bergabung tu, actually we know that to track, especially macam case dekat Silpitaling tu, is not easy. It's not basically it's not just dependent on one agency. So basically teamwork diperlukan, and kerjasama between all agencies berkaitan amat kritikal, sebab masa tu macam Maisarah cakap tadi, semua panik. Kan, kita tak tahu kes tu kat mana, dan to make it more interesting, masa tu pun kita argue berapa ramai sebenarnya jemaah tabligh dekat Silpitaling masa tu. Kita ambil satu kes tu lah. And they have gone back to their hometown semua, so kita tak tahu the spread tu macam mana. Dia punya kataan R0 tu macam mana. So that is the challenge that one agency or one government department ke semua tak boleh handle, sebab dia banyak selok belok, banyak jenis data yang diperlukan, yang sebenarnya dia perlu perbincangan dan teamwork yang amat kuat. Dan kat sini ego kena letak tepi, in which this is, to be honest, period yang 100 hari pertama ni lah MCO ni, for me is a good experience of what analytics for me and the team, because kita gather a different skill set. MOH ada skill set dia, PDRM ada skill set dia, industri ada skill set dia. So basically inilah yang kata apa, kena pandai blend, kena pandai yang kata apa, agihkan tugas, because dia bukan seorang hero pada semua. Macam contoh, macam saya sendiri belajar bila berpasangan dengan MKN, PDRM dengan UTeM ni, what I can see is dia orang punya naluri, dia orang punya insight on investigative mode is very powerful. Kat situ saya belajar. So that baru kita tahu, okay, daripada cara dia buat kerja, how MC can assist MOH in tolong apa-apa juga yang MOH dan PDRM perlukan. Begitu juga kami daripada MCMC juga belajar dengan MOH, okay, wabak ni macam mana dia spread. Sebab dua benda ni adalah berbeza, tetapi skill set tu dia ada. Kalau betul cara, macam Maisarah kata tadi, macam masak, kalau betul cara dia nak masak, insya-Allah sedap. Macam contoh mi goreng, semua orang boleh masak mi goreng, insya-Allah lah kan. Maggi goreng lah, kita ambil Maggi bukan semua orang mampu masak mi goreng, Maggi yang kita enjoy makan, kan. Ada orang dia suka simple, ada orang suka masuk telur, ada orang suka campur macam-macam. So basically kat sini team amat diperlukan, dan team ni dia of course dalam data science dia ada bahagi pada tiga role: data scientist, data engineer and data analyst. All these three memang amat diperlukan, sebab banyak kerja yang perlu diselesaikan. Sebab macam Maisarah kata tadi, masa tu data kita tak tahu mana nak dapat, kan. Sebab polis ada dataset dia sendiri, ATM ada dataset dia sendiri, MOH of course source paling utama ada data dia sendiri. But if all this is not combined, is not properly managed, dia akan jadi insight yang lain, in which macam saya punya penerangan pada setengah session, kita tak nak ambil orang yang macam mana, bila MCC buat analisis, kita tak nak advise, kita pick up, kita katalah kita beritahu MOH kat kawasan ni, PDRM, kawasan ni ada potential COVID cases, kan. Tapi soalan dia adalah, patient tu berada pada pukul berapa? Kita tak nak yang datang, yang positif tu, kita ambil ranking potential patient tu positif, pukul 3 dia pergi premis tu, kita pergi angkut orang pukul 4. Kita buat test. Of course lah, test tu akan jadi negatif. So basically pada masa tu, which is as announced by DG dalam press conference, especially masa 27/3, yang masa sebelum kita buat PKPD pertama di Simpang Renggam dan di Semenyih tu, it was actually a teamwork, macam DJ kata, between agency, between MKN, PDRM, MOH, MCMC, in analysing the right data to get the right person untuk test. Dan masa tu memang saya agree, test masa tu memang very targeted sebab yalah of course we involved in the analysis semua kan kerja MOH. So basically tim yang kuat amat diperlukan sebab semua ada expert dia masing-masing. Dan kat sini yang saya amat puji pada masa ni adalah semua tolak tepi title. Maknanya discussion tu is more really problem use case based. Sebab dalam pengalaman saya, dalam banyak discussion analytics, saya aware juga benda ni bukan berlaku pada masa COVID saja. Sebelum COVID pun, kadang-kadang discussion tu menjadi terbantut disebabkan ada orang pull the title or pull the rank. So scenario discussion analytics to get a strong team, kalau pull rank ataupun orang kata apa, HIPO, highest paid opinion people, kalau itu berlaku, ia akan menjadikan situasi analitik tu dan tim tu susah nak bekerjasama. Bayangkan contoh dalam antara tim yang saya ada tu, ada yang bertaraf lecturer, ada yang bertaraf PhD. Andai katalah ada ataupun even ada yang level vice president, level tinggi lah dalam jawatan swasta pun. Andai katalah mereka ni full rank, saya tak rasa teamwork tu akan berlaku dengan baik. So kat sini again, teamwork amat diperlukan. So bila nak assemble team tu, setiap satu kita identify, okay, dia punya skill set ni, dia punya knowledge dekat mana. So daripada semua ni, team akan ada satu central yang akan discuss dan try to combine and make sense the data before present to management. Masa tu, of course, macam saya kena report pada chairman SMC saya lah. Dan saya percaya MOH ada report di saluran ke sampai ke DG. Dan saya percaya begitu. Dan Alhamdulillah saya percayalah berdasarkan apa yang kita lalui masa 100 hari pertama, kerja kami tu, teamwork kami tu, talent yang ada tu menghasilkan result yang kita dapat lalu Julai tu zero case tempatan lah. Saya percaya faktor itu ada. Itu dari saya so far. Saya serahkan balik pada Doktor.
Alright, okay. Thank you, Encik Azam. So you said just now we need to delegate the task to the right person. So yes. Put aside your egos, put aside everything, and yes. The fact that in order to give meaningful data and information, whereby from the data we're gonna use the data for the public health, meaning to say that from the data itu kita bawa ke public health. Di mana kat sini we do have here Dr. Siti Aisyah yang who is involved in the COVID-19 and also the public health officer. So Doctor, would you mind sharing about the data surveillance in the health? Okay, based on your experience, how this data could help to detect the early warning of the emerging diseases and lead in making decisions. Doctor.
Thank you, Mi. Thank you sebab inviting me juga for this very good platform untuk kita discuss. We've been seeing everyone daripada industri, daripada data scientist, which is good. So before kita cerita pasal data surveillance in health kan, macam Tan Sri KPK Kementerian Kesihatan pernah cakap kan last time, now is a time of public health to shine. So basically sebelum ni orang tak nampak kami di public health ni. So basically my friend akan cari kami bila Aisyah tolong kira sample size. So basically we are at the background. So and when pandemic occur baru kita nampak the rules of public health kan. So which I want to relate back on the data surveillance because this is our routine activity that we did. Yang mana memang aktiviti kita sepanjang masa, especially dekat pejabat kesihatan daerah, dekat Jabatan Kesihatan Negeri dan juga dekat peringkat nasional dekat CPRC kebangsaan. So ini adalah rutin makan orang kata bread and butter kami dekat kesihatan awam. So untuk sebagai di sektor kesihatan awam sendiri as general. So data is not only data. So for us, data ni umpama tools ataupun alatan untuk kami gunakan bagi surveillance activity. Jadi saya suka cerita what is the surveillance activity in public health sebab semua orang tahu perkataan surveillance ni kan basically it's like macam CCTV memantau. So apa punya CCTV kesihatan awam buat ni? So basically in abnormal condition kan macam tak ada berlakunya pandemik, everything is okay. Tapi sebenarnya tak okay sebabnya bila kami dekat kesihatan awam memantau, kita tengok data denggi, kita tengok data TB. So basically this activity had been done at the background. So apa fungsi data ni kepada surveillance dan apa fungsi dia kepada intervensi kesihatan awam? So bila kita cerita data ni, dia adalah alatan kepada surveillance activity. Jadi maksud surveillance activity dalam kesihatan awam ni, by definition, it is an ongoing systematic collection of data collection, collation, analysis, interpretation and dissemination. Ayat dia panjang. So daripada data collected, diinterpret, dianalyze dan disseminate. So it's a cycle. So bila dia cycle, basically data tu kita tak treat dia as data. Macam contohnya, kes COVID 100 kes pada satu daerah. Basically it's only a data. Tapi apa yang kita nak buat adalah cycle. So bila kita tahu 100 tu, what will be the respond? Berapa ramai human resource kita yang perlu kita untuk keluar dan siasat? Apakah punca berlakunya penyebaran? Di mana berlakunya penyebaran itu berlaku? Because what we need is the action, public health action. So public health action ni untuk apa? Untuk mengengkang dan mengawal penyebaran penyakit. Terutama dekat dalam cerita ni kita cerita pasal penyakit berjangkit ataupun COVID-19. So basically bila kita cerita pasal surveillance activity ni, it been done. Yes, benda ni memang dah ada. So kalau kita tengok bagaimana Kementerian Kesihatan, dia punya pelaporan tu dia memang dah standardized. So basically dia punya pelaporan untuk COVID-19 ke, TB ke, denggi ke, dia sama. It start from pejabat kesihatan daerah. Di mana kenapa berlakunya pelaporan itu bermula pada kesihatan daerah sebab pejabat kesihatan daerah menerima pelaporan daripada klinik, daripada hospital yang berdekatan. So any penyakit berjangkit akan dilaporkan ke pejabat kesihatan daerah untuk diorang buat analisis sebagai data surveillance mereka. Jadi kalau dia tengok, diorang akan terus buat action. Di mana dekat pejabat kesihatan daerah itulah ada kita panggil rapid response and rapid assessment team. Jadi dekat situ lah mereka lakukan aktiviti. Jadi bila mereka menerima notifikasi, dia buat verifikasi dan dia akan buat action. Di mana data ini kemudian akan dipulkan di peringkat negeri. So dia akan tengok daerah B, daerah C makin banyak. So mungkin negeri kita akan bertambah. So itulah fungsi data kepada kesihatan awam. So dan kemudian data ini akan pergi ke peringkat nasional ya dekat CPRC kebangsaan. Jadi benda ni kita panggil surveillance system ni, dia memang dah ada. Kita ada active surveillance dan kita ada passive surveillance. So active surveillance ni kita tahulah data-data yang memang kita pantau. Macam contohnya denggi, TB, penyakit-penyakit yang memang dah ada. So benda ni kita akan tengok trend, kita akan pantau ya data-data ni. So kita nak tengok ada berlaku outbreak tak, ada berlaku peningkatan tak, masa bila berlaku peningkatan. That's why kalau kita tengok pada end of 2019, before kita ada COVID-19, perasan tak kita ada outbreak of influenza. So daripada situ cerapan surveillance influenza kita tengok, okay, ada berlakunya outbreak respiratory cluster. So dekat situ kita dah tengok trending sebab data tu memang sentiasa ada. Kita mencerap data daripada pejabat kesihatan daerah tadi. So bila kita tengok ada berlaku spike, kita tengok pula adakah perubahan kepada genomics, simptom, bentuk virus influenza tu sendiri. Oh tak ada. So most likely it's because of human activity and masa tu kita ada perubahan seasonal daripada northern hemisphere and southern hemisphere. Tapi benda ni akan closely monitored. So, dan bila berlaku masa tu kan ada panik, orang nak cari vaksin influenza apa semua. So bila kita dah buat, tengok data kita, analisis kita, so kita akan buat, kita panggil penilaian risiko. So bila kita dengan data yang ada ni, kita analyse dan kita buat penilaian risiko, baru kita boleh inform public. Risiko ni tinggi ke, risiko ni rendah ke, and what they should do dekat public. So and then bila kita cerita pasal COVID-19 ni, this is so special because dia adalah penyakit baru, novel virus. Masa awal tahun 2020 dia adalah novel virus. Jadi benda tu berlaku dekat China kan. So basically active surveillance ni kita memang dah ada standardized. Dengue, kita dah ada TB kan, kita dah ada test dan kita tahu cara bagaimana kita nak diagnosa penyakit-penyakit ni. Bagaimana pula dengan penyakit-penyakit baru? Yang ini kita panggil event based surveillance. Kita ada platform kita panggil event. Any event berlaku di dalam negara ataupun di luar negara, di mana kita cerap maklumat-maklumat ini melalui kenyataan media, daripada rumors. So masa tu saya ingat lagi on December kita dapat news daripada China. Kita gunakan pelbagai platform kita buat carian maklumat setiap hari dan kita buat risk assessment terhadap maklumat-maklumat ni dan kita buat verifikasi. So masa tu kita dapat berita berlakunya wabak unknown pneumonia cluster dekat China. Benda tu kat China lagi tau, kita tak cerita dekat Malaysia. So what we did is kita sebagai kesihatan awam, we have to verify betul ke tak betul kan. So we have to verify the information. So apa platform yang kita gunakan? Kita verify melalui kita punya collaboration with international organization, which is kita ada WHO. So we wrote to WHO, we want to know what will be the risk assessment, what happened in China, so that kita tak tahu kalau betul novel virus yang ada potential untuk pandemik, negara kita kena prepare. So basically based on tak silap saya news tu kita dapat after Christmas dalam 25 sampai early January. So the masa 1st January tu we already receive and verify information from WHO. At that time kita dah start fever screening dekat pintu masuk. That is how the data, the information kita gunakan, kita cerap dan kita apply untuk intervention. So masa tu kita dah ada saringan dekat pintu masuk by 1st of December. While China dia declare this is a novel virus masa 1st January 2020 and 13 January diorang berjaya isolate virus tu, mengatakan dia adalah SARS coronavirus 2. So jenis virus baru. So basically this data will assist us with a platform of surveillance system yang kita ada. So that's why surveillance system ni dia merangkumi disease ataupun penyakit yang sedia ada dan juga berpotensi ataupun sensitive enough to pick up any emerging diseases. So tak semestinya penyakit tu berlaku dekat luar negara. Let's say kalau suddenly negara kita ada outbreak yang kita tak tahu virus apa tiba-tiba kan. So this event based surveillance ataupun syndromic surveillance system yang memang dah ada dekat dalam ni akan digunakan untuk mencerap all this information untuk analysis and digestion dekat peringkat kesihatan awam. So that is how and very important data-data kepada kesihatan awam. Dan kalau kita nampak kan dekat bila saya cerita pasal data rumor surveillance dekat China dulu kan, and we not only purely based on data yang berkaitan dengan health. So kita cerap juga banyak information. Contohnya macam masa kita dapat tahu dia adalah novel virus from Wuhan, China. Kita dah start collect information flight masuk daripada Wuhan bila. All this information akan membantu kita untuk buat kita panggil penilaian risiko. Apakah potensi risiko untuk negara kita mendapat penularan yang sama seperti sana, how fast the infection could be done and how prepare our country to face these challenges ataupun public health event. So itulah kepentingan data dan juga aktiviti surveillance di kesihatan awam. Thank you, Umi. I'll get back to you.
All right, thank you, Doctor. That's very wonderful explanation. So that's the importance of data surveillance ataupun CCTV ni untuk memastikan tracing dan sebagainya lah untuk penyakit, especially for the COVID-19. Alright, we move to the next panel. We do have here Ashila. I believe she's involved in all the modeling and things like that. Even with my experience with the Corona Tracker teams, we came out with the paper of worldwide COVID-19 outbreak data analysis and predictions. Even the modeling part is very difficult. And now we use the SEIR. But still, one model, one size doesn't fit for all. So from your opinion, will you mind enlightening us about how this data modeling can help in the prescriptive and the precisions in the public health? Thank you.
Thank you, Maisara. So I will answer the question by sharing my own personal experience as a data scientist in INCA. So INCA is a digital health company. is very interesting because you see, usually when we hear the word digital health or health tech, we think about EMR, telemedicine, teleconsultation, medical devices. But INCA took it a step further by building a pandemic preparedness center. So we are in the midst of developing IPPC, the International Pandemic Preparedness Center, and IPPC will act as a unified disease surveillance system because traditional surveillance system is usually very disease specific. For example, in Malaysia, right, we have a dengue surveillance system, we have TB surveillance system. There's no unified disease surveillance system. So this is the gap that IPPC is trying to bridge. In IPPC, there is a unique component which is the analytics part known as the power lens, where our focus is more on AI and data science to provide public health insights. So this is where I come in. We have a team of data scientists all over the globe. We have data scientists in the UK, data scientists in Dubai, in Malaysia, such as myself, working around the clock to develop this power lens. We use a mixture of different data streams, from the traditional epidemiological indicators to more unconventional ones such as weather data or data from Google or telecom, where we paid for licenses to use this data. And using the data, we then develop models and disease control analytics to provide insights that can assist decision makers and policy makers. Most recently, we have assisted the Laksana team from MOF in the National Recovery Plan. We also have another project with the WHO Eastern Mediterranean region, where we help to assess how effective the public health and social measure is in reducing the transmission and its impact on the country's economy. You see, healthcare has become digitized, which creates massive new data set. At the individual level, modeling can be used in predictive analytics, where healthcare providers can anticipate how, when, and where care should be provided. For example, AI models have helped clinicians to identify patients at risk for chronic conditions and predict the health risk of the patient as well as the length of stay. And this improves medical diagnosis and healthcare delivery overall, right? But that is at individual level. How about at population level? At a larger scale, big data and models have been used to find larger trends. Using big data, we can stratify the population to predict and understand the public health risks for a more specific subpopulation. This is what we call precision public health. And by using prescriptive models, we can see that if we implement a certain targeted intervention, what would the effect be on the transmission dynamics of that disease? So this is known as the prescriptive analytics. For example, maybe we actually do not need to lock down the whole country, but only certain areas with high risk, right? So these insights can help guide decision makers to implement the correct strategies to improve the overall population health. And scientists have used different approach to model COVID-19 dynamics. The most famous ones are the compartmental model and agent-based model. So the compartmental model are the one that you mentioned before, the SCIR, right? Okay, but some models also use the combination of both. So during COVID-19, mathematical models have been used to predict the course of the pandemic, and this can help to plan effective control strategies and resource allocation, just like what Dr. Siti Aisyah has mentioned. For example, I just wrote my first research paper in INCA together with Dr. Desi Baharaja. So he's the visionary behind IPPC. So in that paper, we use epidemic modeling to study the effects of effective contact tracing in the context of rising vaccination rate. So to summarize, the findings showed that vaccine alone cannot curb the disease in Malaysia, and a very effective contact tracing is important to reduce the transmission. So this means that we need to automate our contact tracing, right? So these are the questions that modeling can help to answer, and with the right experts to interpret the modeling result, it can help decision makers in terms of pandemic planning. Yeah. Okay, thank you. Over back to you.
I think moderator, you need to unmute yourself.
Sorry. Okay. All right. Thank you, Ashila, for your discussion just now, for your insightful explanations. I believe that the data is very important in help the stakeholders to making decisions. I want to pick up one or two questions here. I believe there are one question from the Fairoza before we go further to the second round. As Fairoza said here, how transparent the data is being shared by KKM itself. I believe anyone can ask. Probably Maisara or Azham probably can answer the questions at this moment. Then.
Nak
Because we're
bagi
gonna
lagi
have the
first ke?
transparent questions after the second round. Probably you can just give a highlight, one or two.
Okay, I think in terms of transparency, I think I just share based on my experience masa yang first 100 days MCO tu kan. Dia macam ni. I believe that KKM is transparent. It's just how the data is being shared with the public. Sebab bukan semua data tu is kata apa orang reti pakai kan. Sebab macam contoh macam kerja-kerja yang kami lakukan belakang tabir dulu dengan PDRM, dengan UTeM, dengan MOH, data tu ada yang some of it is very PDPA, very sensitive and very kind of macam akan bagi implikasi yang berbeza kepada maybe business, maybe kepada community, which is dia adalah satu benda yang bukan senang nak just open je. So to be honest, macam kalau kita tengok sekarang pun for the past few days especially, I believe that semakin banyak soalan yang ditanyakan tentang apa yang transpired kat data COVID now dengan data GitHub. Sebab sebelum ni walaupun GitHub tu dah lama buka, tak ada siapa pun tanya sangat on the content of data GitHub except siapa yang follow sidang parlimen hari tu. Kan, yang ataupun memang kaki data lah. Tapi bila adanya COVID now ni, then people asking more because why? Pada kita orang yang dah biasa tengok kat GitHub, benda tu bukan baru. But for those who new, yang baru tahu dan baru nak digest, soalan akan dia banyak. So kat sini sebenarnya for me, data KKM transparent. It's just how they push the data to GitHub and then from that, COVID now ambil for public consumption. So kat sini to be honest, for me, KKM is trying to do something good. It's just perhaps this is satu area yang not just KKM, I believe in the era of since government announce my digital kan, IRA 4.0 polisi yang baru ni, ini adalah satu area yang baru untuk government agencies to share data. Sebab inisiatif open data yang bertahun-tahun sebelum ni pun, last data update is as at 2016-2017 if not mistaken. So ini adalah satu kata apa, arena baru untuk KKM dan juga ada ministry agency untuk share data dan macam mana nak bagi public faham dan orang kata apa, guna untuk moving forward. So nak kata transparent tu sebenarnya pada saya adalah sebenarnya lebih macam ni tau. Amat kelabu in terms of macam mana seseorang tu interpretasikan data tu. In other words, saya nak kata macam ni, semua orang boleh mengira tetapi bukan semua orang boleh mengira dengan betul. That's my opinion.
Okay, thank you Azham. Okay, I think we just take one question first. We have another question coming, but we keep until the end of the second round. So, Maizara, okay, speaking about GitHub, Azham also dah pick up GitHub ni, which is now is open source. Semua orang nak open source, so the source is available. So semua orang nak tahu tentang, everyone want to know about the data transparency and things like that. How you can relate in terms of the quality of the data in the open source and the credentials in generating the information. I believe last week KKM has just announced COVID now, like Azham said, and mind sharing your opinion on this. Perhaps would like to echo what Azham said just now.
Okay. For me, I would like to recognize I would really appreciate what KKM done by exposing this data, because previously, things are harder when we don't have any GitHub data like this. Okay. Although we acknowledge that there is a debate on this action should be done earlier, at least it is something good progress. I would recognize that one. As for me, Okay, I'm not in the public health sector, but rather I'm just what Azham said, kaki data lah. Okay, so I always wanted to know more than just what being published by the infographic in the social media, right? So basically in social media it's very limited to cases by states, okay, and then what else, how many recovered, how many infected, how many deaths. Even for previously the death cases is not broken down into brought in that's in early stage of MCO, right? So as for me, what I did is I need to read from many sources before GitHub even KKM even publish their data to GitHub. So among the sources that I read is from the G Hisham official blog and official COVID-19 website, which is COVID-19. I forgot the name, but it's from KKM, as well as the JKJAV website. Okay, previously people are flooding this website JKJAV because they want to know their status for vaccine, right, and then register for exact vaccine. But it provide more than that. It provide the current statistic on how much have been registered to get vaccine and how much have received first dose and second dose. So for me, what they provide is good for public for consumption. But the thing is, the information is there, but it's not organized into one place like COVID now. So for me, I really appreciate the progress. And then for the information that I need to know, I wanted to know before this, what I did is I need to scrap these websites to get information that I desired information. For example, right, for R not values, they didn't provide a time series data. So for what I did is from my experience, right, I need to scrap that website COVID-19 official website to get the R naught values every day. But of course lah, I didn't serve it every day. I just use automation script and then put it into my own database. So just for the sake of information, there's so much tedious work that I need to do. Okay, and then yeah, beside that, the drawback from my approach previously before GitHub and COVID now, uh okay, I really appreciate the consistency of the reporting. By means that there is some words that like keywords they put, right, like Arnold hari ini adalah berapa, and then Arnold hari ini adalah kekal. So from that keywords I can scrap and then put in the values into my database. But the thing is, for example, there come in another situation. For example, like previously in DG Hisham blog, they reported the details of every dead cases. For example, they of course they didn't expose the patient name, but they exposed the age, the comorbidity, the disease that they got, and then where they are from, and so on. So we get to know every patient's details from there because the dead cases is less than 300 at that time. But since the dead cases surge and then increasing up to 300 cases daily, so in DG Hisham blog, rather than they provide every details of every patient, they just put an image of tables, summarize all the details. So from my method is no longer works. So I really appreciate the progress for the openness of the data. So when we talk about the data that had been released in GitHub, yeah, it's very good approach and progress. If I can remember, it started with the vaccination data, right, by JKJAV. Then KKM followed JKJAV to publish the data too. What I can say is GitHub is a good platform because but not everyone can consume from GitHub. Only the one who know to use GitHub can know lah how to know, right? Because let's say we have any question about the data set, we can just raise a PR. PR is I forgot the what PR means, but you can ask question lah in the GitHub. But the thing is like Azham said, only the one who know to use it can use it. And because the community, usually the community that use GitHub is among the programmers, the data engineers, data professionals, the data analytics, and so on. So as I can say, GitHub is only friendly to one who know how to use it. But for COVID now, I think it's good, but we need some improvement lah. There is some room for improvement. For example, this portal also should deliver effective communication to the consumers or the users. For example, for me, who the one who didn't involve in any public health intervention and so on, I just a normal rakyat. Okay, when I see the graph, okay, I can understand that how many tests has been done. But there is another one thing that is a positivity rate there. For me, I honestly I don't know what is positivity rate refers to. Is it comparing the test to the current infected cases or whatnot? So that's I can say. But for improvement idea that I can say, this because this is interactive portal, it have various pros rather than cons. Because okay, first we can improve it by having a forum or any form for question for the people to ask question, right? Just like GitHub we can raise a PR. Another thing is maybe can perhaps one or two paragraph to describe about every graph, so that at least for the one who don't know anything about that can understand a bit on the graph, what the graph meaning. At the end of the day, what I think is important is to deliver the message to the masses. If we provide various platform, various infographic at it is good. It is like we can say it's open enough, but how can it become effective? How can people understand the situation just by looking at those graph and data? So back to the definition, data is just data, but what make it meaningful is the information delivered. So that's all for me.
Okay, thank you, Maishara. I believe that what you said just now at GitHub is just only for those techies whose kaki data can understand. For those non-techies like me, perhaps like thousand millions Malaysians out there can understand the numbers itself, whether it's signify this or that. Okay, I understood. For the perhaps from the COVID team, COVID now probably they can do some improvement. All right. Okay, back to Encik Azham. Yep, I believe these current situations of COVID-19 is like everyone has their own data set, and it's very challenging in the data management. So, what is your opinions, okay, on these and your suggestions to overcome, these data managements, considering the level of companies, agencies, and also the government? Just
Okay. Thank you, Min. Okay, in regards to the question, let me relate back to the first round and also the recent development. Okay, bila sebut tentang data management semua ni, okay, everyone I believe at least ada data set dalam Excel. Before COVID, I believe many is like macam, okay, semua data cantik, jalan. But once the COVID started, I believe government, agencies, even companies are starting to like feeling data ni dah masuk akal ke tidak? Kan? Cara data to collect everything, because why? Macam contoh macam my experience masa dekat MCMC. Masa tu lah, okay, macam ni lah. Kita ambil satu case scenario that actually is being discussed in the jendela punya lab. Kan, jendela lab is happen masa yang PKPP punya phase. Yang mana salah satu yang didiskuskan adalah komplain tentang services by telco, courier and media. Saya tak nak sebut spesifik mana. Kan? Okay, kita antaranya macam masa mula masa bulan 3 PKP start, bulan 4, bulan 5, komplain yang di-receive oleh MCMC pada ketika itu tidak begitu tinggi. Tetapi masuk je bulan 6, dia mencanak naik. Okay, let's say kita ambil for example contoh telco. Kan, komplain terhadap telco for example, ataupun courier. Ambil telco lah sebab kita cerita PDPR, kita work from home semua ni kan. Berapa ramai yang akan komplain terus ke MCMC masa bulan 3? Biasanya, normally kita human behave, kita dalam that scenario, kita akan komplain kepada provider kita dulu. Okay, first round. Jawapan standard, unfortunately, kita sedang berusaha untuk meningkatkan quality service. Masuk bulan kedua, lagi sekali, kita akan berusaha meningkatkan quality service. Bila masuk bulan ketiga, which is bulan 6 tu, masa ni lah dia ada 3 path yang biasanya orang akan ambil. Satu, dia diam, komplain lagi kat telco. Nombor 2, dia tukar telco. For example lah, kita ambil contoh telco kan. Nombor 3, baru pergi MCMC. So, kalau ambil that scenario, bulan 3, 4, 5, MCMC komplain akan biasa, normal. Bulan 6 akan naik. So, this is one example that I believe also happening in businesses, in other agencies, in other, kita punya own business pun. Masa bulan pertama, kedua, ketiga tu, kita tak rasa apa sangat. Tetapi, along the way, data pattern akan start behave differently. So, kat sini, kalau kat sini pada saya sebenarnya is, COVID in a way is a blessing in terms of data management. Because why? Kat sini barulah akan nampak kind of a stress test of how data collection is being made, how data processing is being done, and how data management is being uruskan in the system. So kat sinilah akan nampak pelbagai hiccup, pelbagai pattern-pattern pelik kan, yang mungkin dulu rasa outlier, sebenarnya dia bukan outlier. It's the actual cases that is happening. So, bila cerita pasal data management in terms of government, private and agencies, because coincidentally, I've been all three, coincidentally, saya nampak ini adalah common problem sebab masa ni akan nampak sebenarnya baru tahu data yang sedia ada tu tak cukup. For example, bila cerita ambil contoh tadi yang masa saya kat MCMC tadi kan, baru tahu macam okay, rupanya kita perlukan data yang lagi lebih bila nak cerita pasal kenapa orang komplain dekat area ni pasal coverage. Macam contoh cerita Viviana dulu. Why? Masa ni lah baru okay, cari data-data apa relevan. That is in terms of government, one case of government. What about business? Kat situlah baru akan tahu okay, sebab apa? Bila COVID ni berlaku, behavior sales, behavior purchase akan bertukar, behavior cost akan bertukar. For example ambil contoh simple. Bila masing-masing work from home, berapa ramai yang jimat kos minyak? Satu. Tapi dalam masa yang sama, berapa ramai yang kos elektrik dia naik? So, for certain people, dia tak perasan benda tu. So, this is where I'm taking from a data analytics, data science perspective in terms of whatever government ke agency ataupun private. This is where you can start to analyze your usage, your cost, your expenses, your sales. This is where you can see back, review balik your business problems yang sebelum dan semasa COVID dan potential moving forward. Tu satu. Nombor 2, revisit balik team setup in terms of data tu. Data team tadi yang I touch on first round tadi. Masa ni lah akan tahu data team tu functional ke tak functional. Cukup orang ke tak cukup orang. Having the right talent ke tidak for data management and data science, data analytics semua ni. Lepas tu bukan pasal talent je, proses, business proses perlu review tak? Sebab mungkin satu-satu business tu ataupun even government agency selama ni buat that service offline, disebabkan oleh COVID, they have to move to online. So kat sini, offline dan online, cara mengurusnya pun berbeza. So again, review proses. Lepas tu support, tech support, IT dia mampu tak? Kan? Ke orang tu jenis seorang IT je, dalam department IT ada, tapi ada 2 orang untuk support the whole organisation. Cukup ke tak cukup? Those kind of things. Kan? Masa itulah baru tahu data storage tak cukup. Masa itulah rupanya banyak data on-prem tak pergi ke cloud. Itu data security tak ada. apa firewall tak cukup, firewall very basic kan, data security memang out, cyber security memang out. So those are the things that for me reveals on moving forward in terms of data management. All these aspects kita kena revisit. Okay, itu baru satu, itu dari segi self process agencies. And for me again, melihatkan pada contoh COVID ni sebenarnya pun, this is where I believe many have realised that even for government, for private, sometimes perlu collaboration. Macam contoh, bila saya dalam lab jendela SME tu, baru macam realise that, okay, data yang ada tu belum cukup untuk plan for jendela. Kena ada, maknanya yang sedia ada tu dah okay, it's just need to enhance in terms of macam contoh bila kita cerita pasal PDPR, bila student universiti kena balik belajar dari rumah. Now, in terms of coverage, semasa persekolahan biasa ataupun orang kata ambil universiti lah, belajar di college dan di rumah jadi lain. So, apa data yang diperlukan? Again, kat sini ada sentuh sikit pasal data management. Reason is this. Saya perasan bila cerita sentuh bab ni, dia nak sedut semua data. Soalan dia adalah, adakah kita nak sedut semua data atau kita ambil data yang relevan? Sebab, macam ni contoh selama ni katalah data storage kita cuma 1 terabyte, data yang kita nak tu 50 terabyte. Ada capacity tak untuk store 50 terabyte? Satu. Nombor dua, ada capacity tak untuk proses 50 terabyte daripada 1 terabyte capacity? Nombor tiga, tahu ke nak select daripada 50 tu nak ambil yang mana? Takkan nak proses semua 50 kot, meletup komputer. So these are the things that for me, be it government, be it private, by agencies, this is the time revisit balik all this, tengok balik data management, tengok balik output of report, make sense or not make sense. Sebab sekarang ni, bila kita nak rebound for orang kata apa, pembukaan ekonomi semula, these are the things that actually can assist in decision making, which is data science. That is one of the function of data science supposed to do. Okay, Umi, that's from me. Serah balik pada Umi.
Alright. Thank you, Azham. So so it's very challenging in data management, getting the right people, getting the right talent. How you can, I mean, like Azham said, blessing in this guy. So data sedia ada, boleh guna pakai atau tidak dan sebagainya. Alright. So we move to Dr. Aisyah. Just now, Azham has just cakap pasal general in challenging in data management. So perhaps what are the biggest challenges in managing data for COVID-19? So I believe in terms of verification process, the backlog issues just now, I mean, like it's happening, and probably perhaps manually cleaning up the data. So Dr. Siti Aisyah, the floor is yours.
Thank you, Umi, for the question. I really like what Azhar mentions on COVID ni kan, COVID pandemic ni is sort of blessing in disguise, and the challenges apa yang kita berlaku sekarang ni dekat negara kita, it was not only Malaysia alone. So worldwide ataupun this is masalah satu dunia, which is in previously especially in kita panggil dekat dalam kesihatan awam, in public health emergency and response and preparedness kan, data management, data planning was, dia adalah satu kerangka yang tak di strengthenkan. We always focus on capacity building, human resource building, response untuk kesihatan awam, but we thought about it, tapi kita tak pernah all out, and it never been tested until COVID datang, which is again saya suka nak cakap sebab COVID ni is one of unprecedented event dekat yang berlaku. Why? Nanti I explain why, and why it's contribute challenges, additional challenges to kita punya data collection, data management. So back to soalan Umi tadi kan, what would be the challenges of data collection, data cleaning, all this data processing. So before saya start on challenges, let us recap back kan, sebab saya pasti benda-benda ni pun macam, I mean sebelum ni kan kita tak pernah tahu and we never know about it. And kalau saya jumpa patient kan, kadang-kadang when we ask kan, okay you boleh report to pejabat kesihatan daerah, and they will be asking me like, pejabat daerah tu apa ya? Pejabat kesihatan daerah tu apa ya? They don't even know ada pejabat kesihatan daerah. So basically kita tahu everyone knows sekarang ni dekat mana pejabat kesihatan daerah, apa nombor telefon pejabat kesihatan, this is very good. So why? Sebab pejabat kesihatan daerah ni dia adalah duta Kementerian Kesihatan dekat lokaliti itu, menjaga kesihatan komuniti pada daerah itu. So kita kena tahulah, so that sebenarnya memang bila tak berlaku outbreak, bila tak berlaku wabak, orang pergi ke pejabat kesihatan daerah untuk bayar saman rokok, untuk bayar saman jumpa tempat pembiakan nyamuk Aedes. But basically dekat situlah berlakunya the magical data collection, data processing, it was started there. So apa yang kita panggil proses untuk kesihatan awam ni, di mana kita cerita tadi kan data surveillance, data collection, data analysis apa semua tu, dia start dengan data notification ataupun disease notification. So dekat Malaysia ni kita ada beberapa penyakit yang mandatory ataupun wajib dinotifikasi oleh medical practitioners. Oleh disebabkan itu, satu doktor jumpa penyakit denggi, mereka diwajibkan dalam Akta 342 untuk menotifikasikan, di mana COVID telah dimasukkan dalam akta tersebut sebagai salah satu penyakit yang wajib dinotifikasikan kepada pejabat kesihatan daerah. So mana-mana doktor dekat Malaysia ni yang dia jumpa pesakit, dia suspek, dia confirm pesakit itu adalah COVID, dia wajib dinotifikasikan ke pejabat kesihatan daerah. So data input. So bila data input ataupun data notifikasi ni, pejabat kesihatan daerah dia akan buat satu lagi proses yang kita panggil verification. Okay, so notifikasi. Yang penting sekarang ni, aim dia is data ni, information yang kita generate ni adalah digunakan untuk decision making, intervention, action. So data yang dihasilkan ataupun information yang di-generate perlulah data yang good quality yang sahih untuk kita buat tindakan yang tepat. Jadi dia ada satu panggil proses verification. Sebagai contoh, kenapa proses verification ni kadang-kadang doktor, because notification ni adalah mandatory. So semua doktor yang jumpa patut melaporkan. Contohnya macam Aisyah pergi klinik A, saya pun buat swab RTK. Tak puas hati, saya pergi pula klinik B, saya buat PCR. So dua input notifikasi masuk ke dalam notification system kita akan diverifikasikan di pejabat kesihatan daerah. Maknanya kita akan tengok data makmal, kita akan tengok kadang-kadang ejaan Aisyah, A-I-S-A-H, masuk dekat makmal ni Aisyah, A-I-S-H-A-H, masuk kat makmal ni. So data ni kita akan matching with dia punya demografik, dan kita masuk juga lokaliti. Kenapa lokaliti ni penting? Macam contohnya, saya dapat COVID dekat daerah A, tapi saya bekerja dekat daerah B, saya buat swab kat daerah B. So kes tu perlu didasifikasikan based on source of infection, sebab kita nak target intervention dekat kawasan berjangkit. So verification process, it took some information, some background. So sebab kadang-kadang kalau kita tengok kan, dia ambil masa bila kes tu positif, we have to like cari call, betul tak cik nama ni apa semua, cik sama tak yang ni, betul tak cik ambil swab ni, because the verification process is very important to filtering all the noise or background information yang daripada notification. Then once the information had verified, it will goes to register. So the registration process, dia mengambil masa bila kes sudah verify, dia register, barulah kes tu akan dikira sebagai kes formal untuk daerah tersebut, untuk negeri tersebut, dan juga untuk national level. So kadang-kadang bila dekat daerah tu dah clean, data dah verify, hantar ke negeri, rupanya ya Allah, semalam dia ambil darah dia ambil swab dekat Selangor, rupa-rupanya dia pergi pula ambil dekat KL, dan data tu perlu verification lagi at that time. So basically because of these stages lah menyebabkan the verification process tu dia ambil masa. Ya, ni kita cerita pasal manual verification, manual system, which is sebenarnya benda ni kita dah buat lama daripada TB, denggi, all the infectious disease, dia perlu melalui proses yang sama. Okay, one good thing about COVID ni dan people start realise, okay, dulu verification process ni is very human touch, nak kena call apa semua. Dan we start to see diorang buat automated verification, kita start guna integrations with the system, kita masukkan sistem A kepada sistem B, dan okay, nombor telefon dia sama, nama dia sama, so okay, orang ni orang yang sama. So this process had been initiated. Jadi kita nampak dekat situ kita dah shocked with the process. So this is something like bukan orang kata all this while benda ni ada, but because there's no urgency for you to use it, to do it. So then dia akan mempercepatkan proses verification. So one good thing about yang Umi tanya pasal challenges, then we go to the step notification. Apa challenges dia? Challenges is of course data duplication. Data duplication tak apa lagi, kita cerita pasal foreigners, Ali blok 404, Ali blok 304,1 Ali. So basically untuk identification pun dah ada masalah on duplication. And alhamdulillah, after 2 years we manage this problem, kan, these challenges getting lesser and lesser. So but not the good thing is case makin banyak lah, so the process need to be done faster. Okay, so verification of course macam saya cakap tadi, it's require human verification, which now we've been address this more on automated. Kita tengok dia rasa ada initiations with this new kita luxuriouskan teknologi yang ada ni. And then the next one is registration. I think once notification and verification you know cepat, case registration akan cepat. Then come the next one. The last one is the investigation, which bagi maybe for public kan, because you want to know a case naik, turun, mati, tambah. But for investigation, it give insight to public health. Kawasan daerah ni banyak yang mati sebab umur elderly ke, because of pregnant lady ke, because of children ke, because it's provide, macam Ashla cakap tadi, prescriptions or predictive analysis of that area, which you can prescribe dekat community tersebut. Inilah yang kita panggil public health precision. So macam contohnya, tak sama macam daerah A dengan daerah B, mungkin berbeza. Macam daerah A, mungkin dia punya targeted population mungkin workplace, foreigners, workplace area. Mungkin dekat daerah B, dia punya target adalah mungkin institutional, orang warga emas. So intervention dia tak boleh sama. Jadi macam kita target, okay, yang ini kita pergi ke kilang-kilang, ke workplace, and then we promote on COVID-19 prevention. While dekat sebelah sini kita address something intervention yang suit to the locality. Apa intervention yang sesuai dekat situ. Okay, that is how actually investigation ni dia akan bagi tahu dekat mana, what would be the source of infection. Is it like one case linked to another case? So, and it require human resource. That's why bila kita tengok cases kan, is it like linking, non-linking? Is it because of the factor contributing it? Because of the search, kita guna perkataan search, number of cases menyebabkan we require such number of capacity. And then one good thing is we have what we call it automations contact tracing. So this is one thing yang very good that it already start initiate. Jadi kita buat verification dah start ada automation, and then investigation ni at least dia akan membantu on investigations of contact tracing automated, so that kita akan strengthenkan kita punya bahagian investigation. Of course yang lain-lain tu macam kita perlu bertanya dia pergi kat mana, pergerakan 40 hari. So it's require analysis, risk assessment, and cara untuk kita bertanya. So it's require still ada human proportion on that part on investigation kan. Tak boleh lah macam kita automatedkan polis kita untuk siasat crime case. So that was the same thing, we cannot automated kan on the investigation process, but we can facilitate. So kita dah nampak dah ada automation, contact tracing, kita gunakan the luxuries of contact tracing punya apps. So this is very good, which is kita nampak, within a year, this progress happened, which the data surveillance of infectious disease had been there for a long time, but for 1 year it give pressure to the system to change. So this is one of the good thing yang Azham kata, and these changes is not only in Malaysia, dekat negara luar pun sama. So if you've been observing kan country punya performance, you can see macam contohnya kita tengok data hari ni dengan data semalam pun kadang-kadang negara-negara pun berubah because they start cleaning the data, updating the data. So it's not only the Malaysians problem, and yet macam Umi kata cerita pasal data backlog. So data backlog we always go back on the search berlaku peningkatan. So did the peningkatan also occur together with our search capacity, human resource? So that is the thing that we have to address. So and this is especially kalau kita cerita pasal now everyone is talking about the deaf data backlog. It was actually lebih kepada we want to have a quality of data that betul-betul tak COVID ni menyebabkan kematian orang ni. Adakah orang tu naik basikal, accident, lepas tu diorang test COVID rupanya. Adakah COVID tu menyebabkan kematian dia ataupun kemalangan tu menyebabkan kematian dia. And then they have to like buka, tengok. Kadang-kadang kita sebab dia accident. Sekali bila kita buat berdasiasat, paru-paru dia dah teruk dah. Mungkin accident tu tak menyebabkan kematian tapi sebab dia sesak nafas. So that is the investigation process that had to be address. So kalau kita tengok country-country lain pun punya masalah. I mean they been reported benda yang sama. So if you look at how UK reported pun sama juga. They had date of death reported and they also have date of death been announced ataupun pronounced untuk case tersebut. So basically this is what macam Azham or Maisara mentioned, the transparency. So I guess that we towards the data transparency, but at the same time we have to give insight what is happening. You tak boleh nak tengok the trend graph turun tu, kematian menurun. But bear in mind because it was not a complete data set yet. So the cautiously interpret is required, so that we inform the risk instead of we informing the data for interpretations of public. So this is very important sebab data ni dia akan digunakan oleh stakeholder untuk decision making. Data ni juga akan digunakan oleh public untuk mereka menilai, untuk risk communication dan juga untuk diorang buat decision macam Maisarah kata nak keluar ke tak, nak masuk ke tak, nak rentas daerah ke tak. So it's also informing the risk to the public so that they can make a correct decision. This is very important. So addressing the challenges, I think I highlighted based on step by step, how we address. And then of course macam Azham kata, into bigger picture, data planning, data management. Of course sebelum kita turun nak ambil sampel, kita kena plan dah untuk data collection kita macam mana. So this is need to be done earlier. So and I think of course kalau kita tengok keadaan sekarang ni macam kita tak cukup ni, kita tak cukup. But if we look into bigger picture, for past 50 years, setahun dua ni dia menyebabkan perubahan yang sangat besar, which I think this is a good progress untuk kita, untuk kesihatan awam, untuk kesihatan semua. I mean health is not only pure to perubatan health, public health, but when we talk about public health, is health for all. So semua orang. So I look it into a positive aspect of it lah. So the challenges need to be addressed, but we have to see how we can assist, facilitate to improve the challenges so that kita semua akan beneficial from that. Thank you, Umi.
Okay, thank you Dr. Siti Aisyah. So I believe everyone noticed the reason of the backlog is requires a lot of things to do. It's not easy to give just simply give a number and things like that. It will take amount of time actually. So we go back to Ashila. Still about the data and modeling and things like that. I believe the modeling itself is not 100% accurate, I believe. So from your opinions and your experience, because you are dealing with a lot of modeling in JE, COVID-19 and things like that, how to ensure, how to understand the result of the model and how to educate the stakeholders in order to match the theory and the practicality in terms of the accuracy?
Thank you, Umi. So that is a very interesting question actually, because you see there is a lot of epidemic models out there. Every day you will get hundreds of new preprints and publications about it. Everyone has their own models, but somehow it is still difficult to understand, especially for a layman, and worse if it led to misinterpretation, right? For example, last time there was a model developed by a team of scientists in America, and it says that there can be a safe way to reopen society amid the rising number of cases. But things didn't go as planned and cases spiked afterwards. So basically, they blamed the model. The model got it all wrong. Even the governor of New York announced in a press release that he doesn't trust the experts anymore. So the statement was quite disappointing. So what happened? Where did the model went wrong? So in reality, there is a lot more going on. Many other factors to consider, such as the social behavior, demography, etc. A lot of things, right? So in order to understand how models can be useful, we first need to understand how they are built, what they can and cannot tell us. And all of this usually get lost in translation. When scientists build an epidemic model, they will write down these assumptions on what they think the reality of an epidemic unfolds. So, and then after that, they will add mathematics, such as the differential equation in your SCIR model, and they can project that reality into several possible futures or possible scenarios. So previously I mentioned there are two famous models in COVID-19, right? The agent-based model and the SCIR model. So in agent-based model, we assume each individual agents have follow a certain rules of behavior, and then we simulate that with how they would interact with each other. But agent-based model is not suitable for a large scale. So that's why SCIR model is often usually we use for a broader perspective. So usually scientists use these models to approximate reality. But reality is complicated, it's uncertain, it's unpredictable, it's chaotic. So there is no such thing as a 100% accurate model that can capture all these possible dynamics of the real world. Like the model prediction is very sensitive to data, how good the data is, if the data is incomplete. So when you don't have good data, you won't have good prediction. Small difference in the parameters will be worse as the disease progresses, right? So another thing is human behavior. There's a huge amount of uncertainty there. Our daily mobility pattern, our contact pattern are out of the norm. So imagine in the absence of data on human behavior, modelers will need to make assumptions. So a small error can have big effect on the model outcome, and even correct assumptions can change over time. So that's why it causes the model to change its course from its original prediction. That is why we say nobody can predict the future. For example, at this month, cases will go down. Or at this month, how many people would die? There is no crystal ball, right? We have to remember that COVID-19 models cannot predict the future. So to me, instead of predictions, what models can offer us is projections. Projections is a bit different. There are these glimpse of possible futures and the different scenarios that we can change. So scientists need to communicate to the public and tell them that they cannot predict the future, but instead they can provide projections under a number of scenarios. Right? So projections generally rely on scenarios, and each scenario is based on assumption about how the future will develop. So we can see the effects of a certain social measures or a certain intervention. How will it impact future projection of cases? When scientists explore the effect of control measures using models, they can actually determine the best combination of control strategies that can help to slow down the transmission dynamics of COVID-19. So so there's a lot of misunderstanding about the application of models, and it's quite dangerous. So the public or anyone, I feel like they need to be well informed about the science behind the models, the dynamics of the disease, the model assumptions first, and also the limitations of the models. Yeah. So that's all for me. Thank you. Over to you, Umi.
Okay, thank you, Angela. So you said just now, nobody can predict the future. The fact is that everyone need to understand the science behind the models. All right, thank you. I believe we go to the very wonderful discussions. I believe we go to the questions. I look at here that a lot of questions to be asked to Dr. Aisa. All right, we go to the first questions from Arif Rahimin. Okay, Assalamualaikum. These are questions toward Dr. Aisa specifically. What is your opinions toward the move that Malaysia made to move into the endemic phase and have to accept that we live with the virus? Thank you. Okay, Doctor, over to you.
Thank you Arif for the question. So ya sebab sekarang ni semua orang cakap pasal pandemic apa semua ni kan. So endemic is not something new, bukan perkataan yang baru, and salah satu penyakit endemik yang orang tak pernah ambil berat sekarang ni adalah dengue. Dengue was endemic in Malaysia, but how we as society or community had respond to dengue sama juga. So basically is how well we are prepared to see ataupun to fight with our disease. So kalau kita tengok kan all these penyakit-penyakit yang disebabkan ataupun yang dihasilkan daripada emerging diseases, emerging diseases ni kita panggil penyakit-penyakit baru. Okay, previously in 2009 we have a novel virus which we call it pandemic H1N1 daripada influenza A, and now bila sebut H1N1 semua orang macam sesama biasa je. So everyone knows about H1N1. So in future dia akan jadi macam tu juga. COVID ni akan jadi macam H1N1 because there are no possibility, tak ada kemungkinan that penyakit ni kita boleh eliminate, kita boleh hapuskan di dunia ini. So we have to deal how to live with it. But the question will arise is how soon, berapa lama benda ni akan jadi endemic, ataupun berapa lama benda ni daripada pandemic boleh jadi endemic. And it's not a decision only by one country. So it require consensus with other countries. Sebab kalau Malaysia je endemic tapi negara lain tak endemic kan, nanti macam mana dia, because world is connected now. Hari ni kita dekat Malaysia, esok mungkin kita dekat US, dekat UK kan. So world is connected. So the decision need to make a consensus based on the world punya decision as well. But the preparations toward endemic mesti mula. Okay, so how we going to say the preparation is not only, kita cerita pasal government punya preparation, but also the community punya preparation. So I really highlighted bila kita cerita pasal public health, kita kena cerita kita punya customer, kita punya orang kata patient kita, which is our customer is the community. So kita kena empower community. We have to inform them bagaimana cara benda ni boleh berjangkit, how we can mitigate dekat dalam community kita. So the preparation ni kita tak ada kata bila government dia bagi tahu okay COVID akan jadi endemic, orang-orang semua bersukaria, so now kita boleh keluar rumah. No, basically the process to be endemic has to be started. So bagaimana kita nak endemic kan is kita start to prepare how we going to live with the virus without getting the infection. Bukan kita kata live with the virus, okay kita symbiosis, so kau ada dekat hidung aku dan kita okay. There's no such thing as that. Okay, so basically macam kita endemic masa dengue kan, and dengue ni endemic. How we going to protect ourselves from getting dengue? Okay, so but one thing about dengue is very simple because kita tahu dia berpunca daripada vector, daripada mosquito. So kita boleh buat fogging, kita boleh buat larvaciding. So there's no mosquito, there will be no Aedes. But untuk COVID kita tahu the transmission is through droplet. Kita tak boleh nak suruh orang pakai mask sentiasa, kita tak boleh nak hapuskan droplet. So how we going to protect ourselves from being infected? So itulah sebab one thing about this novel virus adalah bila dia endemic, dia macam influenza. So selain daripada community kena empower untuk orang kata diorang tahu bagaimana nak protect diri diorang, one thing is this virus dia keep mutate, so tak mustahil dia boleh jadi novel virus yang baru. So close monitoring of these viruses need to be done. Macam influenza, so influenza now everyone is like H1N1 normal circulating virus, but at the background kita dekat kesihatan awam kita panggil sentinel influenza surveillance, whereby siapa yang datang with symptom of ILI, influenza-like illnesses, kita akan ambil swab setiap bulan. Kita ada lebih kurang setiap satu sentinel kena at least ambil swab 5 sampel, even though tak ada outbreak, because we want to know virus tu jenis apa yang circulating, ya, gene apa yang circulating, variant apa, and this need to be shared within the country. So the preparedness dekat dalam community, you have to know bila nak pandemic nanti apa yang you kena buat. So you kena start rutin basuh tangan, everyone had to be vaccinated so that at least you have a minimum protections for yourself kan. Bila you kena sesama batuk, you just stay at home and then you get better. So itu yang kita kena prepare. But yet at this moment, kes masih banyak, variant masih panas. So variant, we still observing, tengok perubahan variants, and then kita masih tengok transmission masih tinggi, kes masih banyak, death masih tinggi. So what would be kita punya effort? So tak semestinya bila kita kata dah endemic, everyone can go out. No, kita kena ambil intervention. Apa yang perlu kita lindungi diri kita? Sebab sekarang ni not everyone is vaccinated kan. So bila tak semua orang, then the virus in the environment is still banyak lah, ya, density dia masih banyak. So itu yang kita sebagai rakyat ataupun community must understand. And for the government, they also have to prepare. Kalau nak jadi endemic, how they going to monitor? Kalau there is any changes in variants, how they going to look? How they're going to continuously monitoring dekat dalam surveillance system kita yang ada. How we want to embed this into kita punya system. So basically, it was not only announce it as endemic, but it's required effort untuk towards to go for endemic. And again, this is not only stop at the country level ataupun government level, but it's going to up to the worldwide. So lepas ni macam mana pula perkongsian data antara satu negara dengan satu negara lain to ensure that one day tiba-tiba dekat Mexico contohnya, variant COVID ni tiba-tiba VOC dia jadi berubah yang lain. So they need to alert the whole world. Kita ada perasan perubahan variant. So everyone need to be prepared. So that thing must be discussed and debated, to ensure that we are prepared worldwide on how we're going to go for endemic. So it's a process. So at the moment for me, kita tahu kita akan ke endemic, but kita equip lah diri kita, baca manual, baca bagaimana diseases transmit, apa simptom-simptomnya. Macam, I always comment on, kalau kita tak kenal, kita tak cinta. So kalau kita tak kenal, kita tak boleh nak elakkan kan. So that is very, very important to prepare ourselves, to prepare the government, to prepare the country, and to prepare the world for, towards endemic of COVID-19.
Okay, thank you, Dr. Aisyah. So I believe moving towards endemic is not only government punya kerja. So it's actually we need to empower the communities. We need to, not only the doctors, we need this data scientists, we need the peoples, we need the NGOs out there to help and to empower the community with the informations, right informations. Alright, another questions also daripada Amni Anwar, also untuk Dr. Aisyah. Okay, how was the risk assessment during the early pandemic, as Dr. Aisyah mentioned just now? Was our country prepared? Sorry, Dr. Aisyah.
Oh, very good question. And I've been asking about this question a few times already. So, but it's very good question. And before pandemic occur on early 2020, Malaysia, we've been evaluated. Untuk world ataupun under WHO, kita ada satu regulation which we call it International Health Regulation. Dekat dalam regulation ni, semua negara dekat dunia telah bersetuju untuk meningkatkan capacity dan capability diorang untuk respond dan prepare ke mana-mana public health event. So public health event ni kita akan refer pada disaster, and at this adalah pandemic. So negara pun startlah prepare apa benda capacity, makmal capacity, human resource capacity, all this capacity, all the collaboration need to be there. So before pandemic occur on early January 2020, on October 2019, WHO with a team, kita panggil Joint External Evaluation Mission. So they consist of several experts from various field come to Malaysia and assess kita punya response and preparedness capacity to public health event. So bila diorang datang, they been like, tengok dokumen, tengok how this work, how the collaboration, and they also make recommendation based on diorang punya assessment. And that time they mentions that Malaysia had capacity and capability to respond to any public health event, including pandemic. So that time, then dia ada make recommendation, which this recommendation, kita akan take out untuk improve kita punya, because one thing about this preparedness kan, selagi benda tu tak ada, selagi event tak berlaku, it never been tested except that kita buat regular monitoring and evaluation. So bila they come and then they make recommendation, and then kita pula ditested with real situation. So on early, so tak sampai 2 bulan that evaluation was met. So kalau kita tengok kan at early initial part of COVID-19 pandemic, we are quite prepared. Kita tengok macam bila berlaku case, we be able to start screening awal, we start mitigate, we start contain the outbreak. So we can see even in first phase and second phase, we managed to be able to control the pandemic too. So I feel that we done good. Okay, tapi again kita kata COVID-19 ni is unprecedented event. Sebab apa? Sebab sebelum ni pandemik tak pernah disebabkan oleh coronavirus. So in 2009 kita ada influenza, keluarga influenza. We never prepared for COVID. Even not kita is Malaysia, but worldwide. So we never had COVID vaccine. So kalau dulu pandemic in 2009 masih influenza virus, they already prepared dia punya technology for influenza punya vaccine. So diorang they just modified, and then within 6 months they be able to produce the vaccine and disseminate. So within 3 years, pandemic influenza H1N1 become normal circulating virus. It's become endemic. Tapi COVID, it took a year to produce, to come up. But the technology is there. One good thing is the technology is there. Because IHR dah mengatakan setiap organisation, setiap country had to prepare for any public health emergency. So kita dah build up technology, build up capacity, build up. So once bila ada benda macam ni, even though you start from scratch, but you already have the technology there, the science is already there. So one good thing is after 1 year we had kita punya vaccine, but virus ni pula dia bermutasi-mutasi, bervariant-variants kan. So and dia punya mutasi is faster daripada influenza. This is something like unprecedented. So that's why bila kita tengok the third wave, kita ada surge of capacity, all these things kan, after 1 year everyone is exhausted. Capacity yang kita ada pun dah orang kata haus kan. So it's occurred throughout. Then we can call it pandemic fatigue. All over country, all over the world dah start penat, capacity dah start exhausted. So this is the thing happen. And I would say that at early stage, I think the preparedness is good. So kalau kita tak prepare, I believe that even masa the first cluster, the largest cluster, kita even there are anticipations that Malaysia could be the largest Southeast Asia COVID importations to other countries, but yet we managed to able to contain, not even to the country tau, sebab that time kita ada lebih kurang we have like 20 plus foreigners from all over the world. So macam mana we been contacting them, kita inform country, orang ni nombor pasport ni ada ni, so we inform them so that they can do a proper contact tracing. So Singapore, Brunei, they be able to contact and trace this person yang datang ke that gathering. So this is how very good Malaysia not only able to contain in the country, but even we contribute to the world. So I think by having additional what will be the experience, I think we can done better lepas ni. If we have like pandemic, of course we anticipate more pandemic after this kan. So I think it's good, but we can improve by the time.
Okay, thank you, Dr. Aisha. Thank you for your explanations about the risk assessment. All right, we move to the next questions from the SM Riza Yamani Jamal Lail. He asked that the zero technology and healthcare, how do we address the issues here in Malaysia? aging and reproductive system, and etc. Perhaps is either Azham or Dr. Aisha or anyone could answer these questions. Azham dulu atau Dr. Aisha?
Azham senyum banyak.
Okay, I think about digital divide ni kan, I think it's not just about Malaysia lah. Kita kalau tengok daripada worldwide pun masuk Malaysia, I think one that we can, kalau kita nak describe soalan ni is kalau kita ambil contoh masa nak implement MySejahtera kan, apa kata software macam MySejahtera ataupun MyTrace ataupun Gerak Malaysia dulu kan. Kadar penerimaan tu masa mula-mula pun download, I think for each apps masa tu pun semua slow masa awal-awal dulu kan, sampai MySejahtera macam government endorse and have everyone to install. Cerita dia sekarang ni pasal this kind of technology and especially on the aging community. Cerita dia, I think kita punya aging community ni bukan yang tak ada civic minded ataupun orang kata apa, for the lack of a better word, kata apa, tak adapt to technology. It's more to, I think it's more to how they see the technology punya purpose of implementation. Kan, macam contoh MySejahtera. Bila nak scan, sebab kita ambil cerita pasal MySejahtera vaksin semua ni kan. Dia cerita dia macam ni. Bila nak pakai MySejahtera nak masuk, dia cerita dia adalah perlu scan ke atau tulis buku. Tu satu. The challenges kat situ, sebab cerita dia sekarang ni adalah how they see MySejahtera addressing in terms of privacy issue. I say privacy issue is not just about MySejahtera. Any apps, even secara, I think yang kata secara jujur kelakar dia adalah bila cerita pasal vaksin ni pun orang kata ada inject chip kan dalam badan ni kan. How many actually resist masa mula-mula pasal vaksin because of percayanya ada chip dalam vaksin. Dan itu bukan sahaja pada golongan aging. Yang muda-muda pun ramai juga percaya. So in the context of Malaysia, I believe the digital gap because of this is actually more to making people understand the purpose of such technology or application being introduced. Sebab cerita dia sekarang ni adalah orang belum nampak dan yakin usaha on teknologi-teknologi yang dihasilkan. Macam contoh, bila masa EZAC dikecualikan daripada program imunisasi kebangsaan. When people tested for the website to apply for EZAC, asalnya yang mempersoalkan that is not just aging community, also the young ones, yang high-tech people pun also question. So kat sini pada saya, specific for this question, in terms of our own environment, it's not because of people not adapting to technology. It's more people understanding how the technology and why the technology is being introduced. Sama juga nanti cerita dia bukan pasal teknologi 5G ni nanti, yang so-called kita nak endkan 3G end of this year and moving towards 5G. So kat sini pun sebenarnya is more to the reasoning and understanding why technology is being introduced. I believe our senior citizen cukup faham pasal teknologi, is just communication on understanding the technology tu rasanya perlu dipergiatkan lah. That's my view on that.
Perhaps Dr. Aisha would like to add more in terms of these questions then.
Okay, I agree with what Azham had mentioned kan, apa yang dia cakap tu. And again, bila kita cerita pasal zero technology technology among geriatric ni kan, so again kita kena tengok rather than kita tengok teknologi itself kan, kita tengok juga in bigger picture. Even though bukan COVID pun, kita tengok bigger picture, the discrepancy of utilization addressing people to use technology, it depends on socio-economic, location, duduk urban areas, rural area, remote area, and then that will be general lagi, kita tak pecahkan lagi into geriatric, and then kita tahu the discrepancy of socio-economic, and then dia ada alat benda tu ke tak, dia ada signal untuk terima ke tak, and then dia tahu guna, like what Azhar mentioned, dia tahu guna ke tidak. And this when we talking about specific group of population geriatric kan, ataupun orang warga emas ni, and in health untuk kesihatan pun, this is not one of challenges that we address semasa COVID ni juga. Macam contohnya appointment system dekat klinik kan, especially untuk warga emas, we have to tailor sort that is very simple. Bila kita hantar SMS, dia boleh baca, oh dia punya appointment pada pukul 10.30 pagi. So that is addressing the technology to them. So dia banyak faktor lain, macam contohnya kan, when we luxurious of the technology, tak boleh font kecil ni, dia kena font besar sikit, and then how the colour of the font. So it had multiple factor contributing to it. And again, bila kita cerita pasal benda ni yang kita tengah develop, yang after sometimes klinik-klinik kita utilization of technology among geriatric. So when pandemic come, COVID datang, dan dia kena cerap that information too fast, pun dia memberi challenges, big challenges. So we have to address this problem, especially kalau kita nak result tu faster. Then kita start tengok ada movement yang macam they assist, membantu warga emas untuk daftar dekat dalam MySejahtera, how they get appointment. Sebab sekarang ni kita tengok CAC pun visual online. So we have to assist and facilitate this a group of people for them to utilize the technology, especially bila dalam masa jangka yang pendek ni. So it is a big challenges which macam selama dah masalah yang lama, but now dia akan pressurize dan dia punya challenges tu must be addressed in faster way. So this is the thing yang I can see how this geriatric technology and healthcare is one of the challenges in not only Malaysia, I guess in worldwide.
All right. Thank you, Dr. Aisha. I believe the other questions, Ayib, he asking about the model they use in the paper. I believe my friends already shared the paper where me and my friends we do collaborate. We came out with the paper, the contractors worldwide COVID-19 outbreak data analysis and predictions. Because I'm not in positions to advise in terms of how we're going to improve the model in the future, because I'm not in the part of the doing that things. But I think we are gonna end the second round, and I believe we're gonna have a last way forward for each every panelist here. Perhaps we're gonna start with Mai Sarah as the kaki data here. What's gonna be your last words then?
Okay, first I will emphasize on what we have lost during this pandemic. So as for the kids in the education, our kids have lost about 2 years of education. What I can hope for is there will be policy for education recovery, not only for healthcare and economic sectors, but we need also to focus on how we're gonna redeem the lost the education years that have been lost by the kids. I believe that there are studies of the well-being of kids during the pandemic and how they adapt to the online class. The data on the I mean, if the policymaker want to address this issue, I would suggest to match the data. I mean, to see the data on academic performance and academic performance, well-being, as well as the student background as well. One of the study that I have highlight this issue are from UNICEF and UNFPA. From the study itself, one of the findings that they found is single mothers are the most affected group. Single mothers, not only single mothers, but they are from a lower income group. Unlike students with parents who can afford to have multiple devices, conducive environments, students with many siblings need to take turns for their class. From what we can see that there is a disparity in education. So what we're gonna do with the education policy? Education system should not left this group, this student who have postponed their studies for about 2 years. Should there be a way to empower them, bring them back to the same track as the rest of the student? I would for me, I think education is not a privilege, but it is a human right. Because okay, when we talk about education, then we need to talk about the workforce in the futures. Because they lost their education for about 2 years. How about they want to compete with the one who got lost their job? Yeah, if the fresh grads who are graduating during this pandemic, and then how about the people who want to go, who want to survive this way, because many people already lost their job, and the competition, I would say, is very fierce. Yeah, so we need to reclaim back the education years that have been lost. Another one is welfare of the kids who lost their parents during pandemic. As of this matter, I heard that there's a plan to set up the foundation to support this kid who lost their parents, right? I hope it will be realized and further assist with well-being of the kids. Same as the education recovery, I would suggest that we could utilize the demographic data of the kids. A foundation is good, but what more important is the coordination. Maybe perhaps in kids in Lembah Kelang might get the better reach, but how about kids from other state, right? So that's the only hope that I have for the for us to moving from pandemic into endemic. Between them are the recovery stage. So for this recovery stage, I really hope that we did something to go back to our normal normal life that we have left before. That's all.
All right. Thank you, Maisara. So that's your what's next. What's next. COVID-19 in Malaysia. So you touch upon the well-being of children. Go back to the normal life and things like that. Okay. We gonna invite Ashila. What is your thoughts? I mean, like after our discussions, the modeling, the description, predictive, and things like that. Perhaps you have thoughts to say, Ashila.
Yeah. So I've seen a lot of people asking. I have a background in pharmacy. I have a background in computer science. Can I? How can I enter in disease modeling field? Right. So for those aspiring data scientists or disease modelers, I just want to say before you build models, you must know you cannot do it alone because you will tend to misinterpret the result, and this could lead to wrong insights. So you would need public health specialists, medical doctors, EPID people. They have the domain knowledge. You would need mathematicians, for example, if you want to build statistical model. Okay, statisticians and mathematicians would know what assumptions that you must not violate. So something like that. You also need programmers, coders, right? So you need all these people to build a very strong modeling team. So just like our speakers today, we have medical doctors, we have data analysts, we have coders here, we have mathematicians. Okay, so we need a multidisciplinary team. And then maybe next is to policymakers and stakeholders. It's important to make data-driven decisions, and I hope that you would utilize results from modeling studies that is out there to plan the way forward for Malaysia. So that's my hope. Yeah, thank you.
All right. Thank you, Ashila. So you said that the teams. I mean, like in order to help the stakeholders to make a decision. So you have this bunch of a team, not only from the data scientists, not only from the doctors. I bet from people from the social science also important because you're gonna understand the behavior of the peoples. So yeah, that's your way forward. So we're gonna invite Dr. Aisha to say some things. Okay, after our discussions.
So thank you, Umi, and I guess I really like this new code that I learned recently. So the difference between partnership and collaboration. So the partnership is like Korean dish. Dia ada banchan and then it comes with separate plate kan. So but you have to eat all to taste everything. But a collaboration is more like Laksa Sarawak, we have like everything inside it and then you mix it and you eat it. So we require more collaboration. I feel like I'm quite happy this pandemic actually addressed how important our collaboration. In one time, we never thought that data science and medical practitioner, we can work together. Now we complement each other. There's no one who are superior than this one. Everyone need to be there to complement each and every one, so that we can come up with good model, we can come up with a good data, good quality and timely data and information right to the public, right to the stakeholder, which is, I think, this pandemic, we address this, dan I hope that sekarang ni orang dah takes out data management, data planning is very important preparedness untuk any public health event later on. So COVID ni adalah salah satu contoh that if you don't plan your data properly, we don't address that the importance of the data management team, it will be chaos. So this is very good example that we can take up, kita learn, relearn, and then we can use it as our, kita panggil improvement for the future. Sebab of course this is not the end of pandemic. We're going to face more pandemic in future. So, and kita nampak daripada tahun-tahun sebelum ni kan, the gap between one pandemic to another pandemic is getting closer. So kita akan nampak more pandemic, more public health events, something like this. So, and then we address this issue, this collaboration kan. We've been working with Ashila, Azhar, Maisara, Umi, and this is very good example. And of course kita akan nampak the negative side and the positive side, but I always take anything, it's supposed to be a platform for us to improve. So thank you Umi, and thank you Y for inviting me, orang yang macam did not have a proper background on data science, but alhamdulillah we managed to share and sharing our experience this afternoon. Thank you.
All right, thank you, Dr. Aisha. I love the words that collaborations, I believe, is complement each other. So, because in future there's a lot of chaos and a lot of, this is what we unknown, not sure. So, starts from now is a blessing in disguise. We have this everyone gathering here. And last but not least, Cik Azham, probably your final thoughts of the round of two rounds of discussions.
Jarang lelaki have the final say ni.
Seorang dia.
Just a pun, sorry. Okay, looking at things in a perspective of moving forward, and kita dalam konteks moving forward kan. Okay, I would like us, especially the KKM critics, especially in this case, COVID critics, let's reflect that on our way of doing things. For example, kita mengkritik data updated KKM daily basis macam mana. So the next question that we should ask is how we use that, have been practicing in our own practice. Kita lebih kurang KKM ke atau kita much better? If much better, alhamdulillah. If much better, in any ways, what can be improvised? That's one for example. Satu. Nombor dua, I think masa COVID ni, kita akan tengok how actually business continuity plan yang dalam kertas lama ni, kat dalam rak tu, terpakai atau tak terpakai. Sebab bila kita nak cerita pasal reopening economy, BCP is actually one of the way that actually kita boleh refer on moving forward. So now the question is, how practical BCP tu dah ada in each business organisation, be it government, private or agencies. How much BCP tu functional in the event that COVID happens. Because why? Bila kita nak live towards endemic ni, in other words, they may be, na'udzubillah, that our colleagues found positive COVID. Soalan dia adalah, office sanggup tak nak bagi MC 14 hari? And how the work done that's supposed to be carried out by the patient, carried out by the colleagues. So sini way forward that actually kita pun perlu revisit balik whatever critics that we have of KKM, whatever it is, look back at ourselves in reopening the economy and rebuilding the economy, how much we can improve. And I believe kat mana-mana sudut pun data, analysis, talent, process akan be in question. Because why? In the era of industry forward, all this akan jadi catalyst or kind of, in lack of better words, a killer for a business organisation because of tak moving forward. You see, because macam contoh, kalau kita nak kata sebab COVID ekonomi tak berapa bagus, the question that we should ask next is, macam mana some business survive? Especially kalau business tu dulu sama-sama, contohlah buka gerai makan kan. Macam mana bisnes gerai makan tu boleh hidup, kita punya gerai bisnes makan tak boleh hidup. For example, macam contoh yang saya sebenarnya, to be honest kalau tengok masa COVID ni, yang saya paling rindukan adalah bukan roti canai tau. Sebab roti canai boleh order Foodpanda. Goreng pisang. Berapa ramai sini yang dah lama gila tak makan goreng pisang. I'm looking in that context. So basically opportunity ada. So is how sekarang ni kita revisit skill-skill yang ada. Macam contoh yang, to be honest, for me, skill in terms of data professional in Malaysia, yes, mungkin in certain perspective tak banyak, tak cukup. Tetapi apa yang saya perhatikan daripada day one COVID sampai sekarang, sebenarnya ramai yang menterjemahkan skill mereka dalam bentuk dashboard vaksin, dashboard COVID for their own. The question that I want to ask is, how much of that skills that you have, you try to impress the public or try to inform the public, you use that for your own organisation? Guna ke tak guna? Kan? So, I believe lepas ni kalau bos-bos tanya tu, prepare yourself, sorry. But this is a honest question that I also ask myself. Sebab this is the question bila, contoh, bila my service, orang kata apa, dah tak service with MOH masa lepas Jun tu, I use the same knowledge experience to assist in lab jendela dan juga pre-lab for package, for courier, for MCMC masa tu. I use that because why? Okay, dah lalu COVID, so I see that satu, syukur masa tu tak ada kluster courier atau kluster telco. Tak ada dalam announcement pun. So, my preparation for MCMC masa tu, lepas dah keluar daripada team analytics COVID ni, what MCMC can do to ensure industry players under MCMC care can go through COVID ni. That is my question masa I kat MCMC. So if I'm in any organisation pun, I akan ask the similar question. How can we move forward from this? Sebab I believe masa COVID ni ramai yang tunjuk skill analytics and data science. Ramai, terlalu ramai. Soalan saya adalah, my question to all of us, how much you have used that for your own organisation? That is my kind of my final, last but not least speech lah. Thank you Umi, thank you all, thank you Y.
Alright, thank you. So kita bagi dia soalan, dia bagi balik soalan dekat kita. So how you use your data for the betterment of your company? So I mean, this is the end of our session, the end of our forums. Thank you very much for Maisara, Dr. Aisyah, Ashila dan juga Azham. Thank you for listening and tuning in, and thank you for all the questions that you asked previously. And thank you, Y, for inviting us and giving these platforms. So we're gonna take a morning break, and we're gonna have, we do have a lunch break from 12:45 until 2 p.m. and we're gonna have more exciting events in Y Summit at UTeM. Stay tuned. Stay safe, and thank you very much. Thank you then. Bye-bye. Assalamualaikum.
Hi, I am Faruza Amira.
Hi, I'm Gita.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Sakina Si Ahmad.
Hi, I'm Khalida Jassi.
Hi, Assalamualaikum. I am Nur Intan Raihana Ruhayim.
Hello everyone, I am Nur Zarin Zulkarnain.
Assalamualaikum and hi, I am Hamira Hadia Abdurrahman.
Hi, my name is Farizana binti Hamzah.
Hi, my name is Nurul Akila.
I am currently a data scientist at ST Microelectronics and Chief Operating Officer at Ever AI Technologies.
I'm also the founder of startup Jenga.
Currently, I'm Associate Professor in the Department of Intelligent Computing and Analytics, UTeM.
I'm also a statistician at WAI.
I am currently a senior lecturer at the School of Computer Sciences, University Science Malaysia.
Currently, I am a senior lecturer at the Faculty of Information and Communication Technology, University Technical Malaysia Melaka.
I'm also a senior lecturer at the Faculty of Industrial Management, University Malaysia Pahang.
And currently a second year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Currently a final year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Women in AI is awesome,
engaging,
remarkable,
passionate and dedicated,
and a great platform for building friendships.
So let's join Women in AI Malaysia Summit.